Tradoon.
Dur.
Tradoon.
Dirter.
Tradoon.
We come to this place for science. We come to paleontologizing streams to laugh, to cry, to show up late and then ask what today's topic is even though it's right there in the title. Because we need that. All of us. That indescribable feeling we get when the surf rock starts, and we learn something we've never known before. Not just entertained but somehow infotained, together. Baffling images on a tiny computer screen. Sound that I can feel.
Dirter. A dirter is one of those things you get at the end of the paper towels, the cardboard thing in the middle, you go dir, dir, dir in it.
Genus names I can mispronounce.
Tradoon.
Somehow, extinction feels good in a place like this. Our common ancestors feel like the best part of us. And dinosaurs feel like they're still around. Because here, they are. Paleontologizing streams, we make fossils less dead.
Well, hello everybody. Welcome back to Paleontologizing. It's really good to have all of you here today. Happy Monday. If it is Monday where you are, for some of you in time zones more advanced than my own, it's already a different day, Tuesday even. But anyway, whatever day it happens to be, whether you're watching this live, hello chat, or whether you're watching later on in the future, in the VOD or on YouTube, I'm glad you're here. Welcome to Paleontologizing. We're gonna have a fun stream today. Thank you, Disco Fountain, for the 5 months of support. I really appreciate that. Thank you. Yeah. Man, have I had a busy last 4 days, or whatever it's been. Thank you, Disco Fountain, for those 5 months.
It's been a long year.
And all of a sudden 4-2, thank you for the 9 months earlier at tier 2. Thank you. All of a sudden, I appreciate you. Holy cow. Yeah. Man, things have been busy. I am on my way to North Dakota on Friday morning. My flight leaves at like 6 a.m. or something crazy like that. It's, yeah. I got a lot that I've got to take care of before we get there. I'm hoping I can stream my normal schedule this week, Monday through Thursday, but there is a chance I'll have to take one of those days off. Maybe Wednesday. We'll see. Because there's just so much to get together. Again, I'm going to be visiting the Badlands Dinosaur Museum in Dickinson, North Dakota. Going to be hanging out with Denver and Liz, some of my old comrades. Badlands Dinosaur Museum. Here we go. We're going to be doing some streams from here, which is going to require a tremendous amount of technical work to make sure that everything functions properly. The internet speeds in North Dakota are notoriously slow. I'm planning on using satellite internet, but that's going to require a whole Wi-Fi mesh network that I'm going to have to establish in here so that I can walk around the museum. It's going to be a whole thing, but I'm working hard on that for all of you, and I'm really excited to showcase this incredible museum. It doesn't look like this right now. There's actually new displays that Stegosaurus is actually upright. There's a number of dinosaur holotypes that are on display here. It's really something. Oh man, I can't wait to show you. And HD and HB
hold a special magnetism for children.
Thank you. They do act like magnets against children,
18
huh?
months. That's almost a whole year.
Thank you for those 18 months, HD. It is almost a whole year. Holy cow. I appreciate you. Yeah. Anywho. Yeah. And thank you, Upstairs Down. What is this? Thank you. Gotta log in. And it looks like they had a site redesign and there we go. There it is. Thank you. Towards satellite internet costs, I really appreciate that, Upstairs Down. Thank you for that. That is very kind and thoughtful of you. I appreciate your contribution there, and it will help. This isn't going to be the cheapest trip. There's airfare and hotel and satellite internet and Wi-Fi mesh setup and all of that. Starlink doesn't make it easy, I'm putting it that way. I had a real devil of a time yesterday trying to get everything working. So Upstairs Down, this helps. Thank you very much for that. Yeah. But yeah, good stuff. Yeah, shoot, where are my manners? For anybody who might be new here, allow me to introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. The whole purpose of this channel is to try and give people an inside look into how fossil science works. Why it's important to your everyday life. Why you should care about the history of life on our planet. I hope that by giving people a peek into how fossil scientists do their work, that it helps it feel more relevant, that it feels more immediate, that it helps get you excited about the idea that we get to know anything at all about what life was like millions, tens of millions, hundreds of millions of years ago on our planet Earth. In many ways, the past is the key to the present. And paleontology gives us this remarkable perspective that no other field of science really can in quite the same way. When you have an understanding of what the history of life has been like past 3 or 4 billion years, when you've got that kind of an understanding, it changes your outlook on life a little bit in ways that I think are really cool and important, and I'm here to share that with you. So welcome. As a dinosaur paleontologist, I work on dinosaurs primarily. Dinosaurs are what I study, what I publish on in the scientific literature, what I present on at scientific conferences, what I dig up during the summers, and I'm very much looking forward to doing that again this next summer and broadcasting it live for anybody to watch who would like to. Yeah, I'm super lucky to be able to do this full time. This is actually how I make my living, is doing science outreach here on Twitch. It's been a dream come true, and I am deeply, deeply grateful to everybody who makes that possible through their financial contributions. So thank you very much for that. Yeah. And where are the vertebrates of the fossil in the background? Oh, official Curly TV, the vertebrae? These? Yeah. Vertebrae on our Plateosaurus right there. 1, 2, 3 vertebrae. Does that make sense? Yeah. Alright, let's see here. Oh, and Anakin Gabriel. I'm sorry, the what? The who? I didn't catch that. One more time? Would you mind repeating? Again? One more time? Anakin Gabriel, thank you so much for the 13 months of the what? The who?
13 months of learning. I would like to take this opportunity to ask, have you ever talked about the Tanis fossil site?
A little bit,
part of
yeah.
the Hell Creek Formation? I
Yeah.
think it would be an interesting topic for someday if it hasn't already been covered. I may have asked about it before. I don't know for sure, lol.
Anakin Gabriel, thank you so much for those 13 months. I truly appreciate that. Thank you. There's a lot of controversy about the Tanis site in North Dakota. I'm not going to be visiting there on this trip out to North Dakota. Not many people get to visit. It's on private land. The crews that have been working that site tend to be very hush-hush about it. Crew, I should say. It's one crew. And there's some controversy, some, let's say, unsavoriness about, how do I put this in a way that's there's some doubts about how valid a lot of the data are that come from that site, and whether the geological interpretations of that site are actually correct. And there's not been a lot of transparency about it. I'm not there on the ground. I'm not super involved with this. I'm sorry, the what? The who? I didn't catch that. One more time. Would you mind repeating? I just keep talking over it again and again, and I'm not really catching what you're saying. Neverwinter Fool, thank you so much for those 13 months. Holy cow. The what? The who? Neverwinter, thank you. Anywho, yeah. I was able to get some insider info, which I'm not really at liberty to share. When I was in North Dakota back in October. Suffice it to say that a lot of people in the paleontological community are skeptical about many of the tennis site goings-on and data there and all that stuff. So, we'll see. That's the cool thing about science, is that the whole point is that we're trying to figure out what's true. We don't take things based on the authority of any one person. We don't... We try not to assume things. If you really want to figure out what's true, you gotta test ideas. You've gotta see where you might be wrong. You've gotta kind of...
Dinosaurs hold a special magnetism.
MLS,
for children.
thank you for those 18 months. I appreciate it very much. Thank you, MLS.
Paleo dance.
So yeah. Yeah. Danny's diplomatic muscles are getting a workout here, says Charlie Dragon. Yeah, definitely. Anywho. Yeah. And upstairs down. Always nervous about commercial interest at digs/excavations. Yeah, they have a tendency to be shadier in paleo than they are in archaeology. My humble opinion. There's a lot of, since it's a much narrower field, it's much smaller, and dinosaurs especially are big business. If people want to sell dinosaur fossils, they're able to get other people to spend obscene amounts of money purchasing them. In a way that I find baffling, These things cost pennies to dig up. Relatively speaking, compared to what they sell for. So, yeah, I don't know. Yeah. Anywho, apparently there will be some stuff coming out about that at some point in the future, Neverwinter. We'll see about that. Voidcrawler, how are you doing? Hello. Yeah. And peer review is the glue of science in a lot of ways, Bondo Latour. Yeah. Anakin Gabriel. Yeah, thank you for the question. Dusty Gale says, how does the term bird brain relate to dinosaurs? Oh, here's the thing. If you ever hear somebody call someone else a bird brain, you can rest assured they don't know very much about birds. Birds are, pound for pound, some of the most intelligent creatures on our planet. They're capable of... Certain species of bird in particular are capable of incredible problem solving, creativity. Birds are smart. They're clever critters, by and large. Intelligence, whatever that is, varies across aves, across the bird family tree, but there are certain groups of birds, things like parrots, things like corvids, which are crows and ravens and jays and things like that, that are remarkably intelligent. Some of them can solve puzzles that, like, a 6-year-old child would be absolutely stumped by. And so since birds are dinosaurs, Dusty Gale, it kind of challenges some old assumptions that people had about dinosaurs. Oh, they were, animals with tiny brains. They must have been incredibly stupid. They didn't have complex behaviors. They weren't social or particularly active or dynamic animals. Nowadays, all the evidence points completely the opposite direction. Which makes sense when we now know that birds are living dinosaurs, and the architecture of their brains, at least in part, was inherited from their dinosaur ancestors. Since birds today are pretty darn clever, by and large, and they exhibit all kinds of complex behaviors, when we start to see evidence of complex behaviors in the fossil record for non-bird dinosaurs, it kind of clicks. It kind of makes sense. It makes more sense than it would have before, now that we know that birds are dinosaur descendants. But yeah. Bondo says, magpies have a greater brain-to-body weight ratio than humans. Absolutely, yeah. Part of that is that magpies are volant. They fly. Birds are weird in that respect. Birds are weird animals in the sense that most of them can fly. And flight is one of these really specialized, highly expensive kind of activities. Like, your whole body has to be optimized for flight. It's really kind of a no compromises kind of activity. And so because of that, magpies and other birds they tend to be very, very lightweight compared to their volume. So they're not dense. They're not dense animals. So yeah. HD says, dumb as a dodo. That's the thing, is that, I'm sure dodos weren't the most intelligent bird that's ever lived. There's no reason to suggest that they were particularly unintelligent animals. These were really successful critters. Dodos existed on the island of Mauritius for 4 million years or something? And they thrived in that ecosystem. They were a keystone species. And then human beings arrive, start killing the dodos, start taking their eggs, introduce cats and rats and pigs and dogs. All of these animals that are, prone to eating eggs that they find on the ground. And the dodo went extinct within, I think it was less than 80 years after it was first discovered. Completely gone. Extinct. Just like that. And this is at a time when a lot of people didn't even believe in the idea of extinction. They thought it was impossible. But yeah. And hey, Racodactylus, how are you doing? Hello. Welcome. And Bono says, dodos didn't have any natural predators and had no reason to fear. I mean, yeah. That's only part of it, but yeah. You're right. Yeah. Anywho, Eddie Scarn says, did Triceratops have cheeks? I suspect they would have, but how far forward did they go along the lower jaw is a good question. I don't know. When we're looking at animals like Triceratops, we know they've got this big keratinous beak on the front of their head, on the end of their snout right there, this big beaky rostrum. And then they had chewing teeth. Chewing or at least shearing teeth on their upper and lower jaws. So we know that these are animals that processed food prior to swallowing it. They didn't just kind of crop and then swallow food like a lot of other dinosaurs. So dinosaurs like Diplodocus, for instance, here. Here we are. So these guys only had teeth at the front of their mouths. And this denotes habits where they would just kind of use this to snip plants, and then they'd swallow everything whole. These narrow pencil-like teeth that they have, not adapted for chewing at all. In fact, there's a chance that they even use these teeth just to kind of strip the little leaflets off of ferns and other plants like that. And then just swallow all of that whole. These are probably ground-level browsers, despite their really long necks. Those long necks would have allowed them to kind of sweep over a wide arc and just gobble up all of the plants in an arc like that, then take a few steps and do it again. Very efficient way of feeding. But they're not chewing in a way that a dinosaur like Triceratops was. So they've got chewing teeth in the backs of their mouths. And one of the cool things about cheeks is it allows you to chew your food without it all spilling out of the side of your head, you know? If they've got cheeks to help hold the stuff in place as they're chewing it, then that makes a lot of sense. So I suspect that most ornithischian dinosaurs probably had cheeks. I'm not a specialist in this kind of area. I don't actually work on, like, reconstructing the soft tissue anatomy of dinosaurs. But, yeah. But yeah, I think Triceratops and a lot of the other beaky plant-eating dinosaurs would have had cheeks, but how far forward they go on the jaw? It's difficult to surmise. That being said, you move out to other groups of dinosaurs, like, for instance, Tyrannosaurus. Here's a really lovely Tarbosaurus right here. One of the things that you often see in dinosaur reconstructions like this, I'll show you my Tyrannosaurus maquette that I have here, is that, yeah, often they're not really reconstructed with cheeks, but there is this, I forget what it's called, but like a kind of a pink fleshy part right there at the back of their mouth, near the articulation point between the lower and upper jaw. You see that in reconstructions like this too. So they've almost got a jowly thing going on, where they've got this down here. There's kind of a swoop down like that, around like the jugal bone. Really interesting talk at SVP this year. I think it's okay for me to mention this one part. There's some evidence to suggest that there may have just been kind of stretchy skin that went from the cheek here down to the lower jaw. So you wouldn't have had that line there at all. In fact, there may have been like a jaw muscle going over that, which is weird to think about, but we see similar things in birds today, in certain birds. So you're probably going to see more dinosaur reconstructions, especially like of tyrannosaurs and theropods like that, where there's just a jaw muscle that's covering over that gap between the upper and lower jaw there. So instead of that, pink bit of flesh right there, instead just skin over this, covering a big jaw muscle. It's really interesting to think about. But yeah. Anyhow, I hope that makes sense. Yeah, I'm excited for when some of this stuff finally gets published. And let's see. Valerian Hunter says, have you heard of COSI Science Center this weekend? I don't know if I have. Where is that? COSI Science Center. One of the exhibits heavily focused on T-Rex. Very cool. COSI Science Center. Oh, in Columbus, Ohio. Interesting. Center of Science and Industry. And look at that. Wow.
This is it.
Oh.
This is the horizon, which marks the extinction of the dinosaurs.
Hang on a second.
Below this level, and out in here, there are dinosaur fossils.
Nemo Lock.
Above this level, on these rocks, there are no dinosaur fossils. So I'm actually
Welcome.
standing on the level that marks the extinction of the dinosaurs.
Hello, Nemo Lock.
And their 9 raiders have stumbled
And
below
Raiders.
that level.
How are you doing? Welcome to Paleontologizing. It's good to have you here. Holy cow. Nemo Lock, I hope you had a wonderful stream. Welcome to Paleontologizing. It's great to have you. My name is Danny Anduza. I'm a dinosaur paleontologist. I study dinosaurs. I publish on dinosaurs in the scientific literature. I talk about dinosaurs here on Twitch, and I dig up dinosaurs during the summers. Past 3 years, we were very lucky to be able to stream that live, and I'm looking forward to doing even more of that this next summer. And Critical Levels of Honk, how are you doing? Welcome to Paleontologizing. Hello. And are those Ankylosaur emotes? Very nice. Nemo Log, very, very cool. Yeah. Anywho, good stuff. Yeah. Emilux says, hello, Danny. I also love dinosaurs. Well, you're in good company. Welcome to the channel. Have fossils and plan to do a fossil stream at some point soon. Very cool. Wow. Best of luck with that. I hope it goes great. Yeah. Let me know if you've got any questions. I've been really busy lately. Oh. Nero Crab. Thank you. For the follow. Welcome to Paleontologizing. I've been really busy lately getting ready for this trip to North Dakota. I'm leaving on Friday. I'm gonna be linking up with some friends and colleagues and finally getting a manuscript done so we can get it submitted for publication. Something I've been working on for years. So it's going to be really good to have that done. And then we're going to be doing some streams from their museum on Monday and Tuesday next week. Provided I can get all the streaming equipment to work properly. Having some real difficulty with the satellite internet setup. But, yeah, anywho. I'm excited about this. I'm really excited to be able to show you around. And it's an excellent museum. Nero Crab says, I'm surprised you're the exact image that my brain comes up with when I think about a cool paleontology dude. Oh, Nero Crab, I appreciate you saying that. I'll take that as a compliment. It also makes me slightly self-conscious just in the sense that if I am perfectly conforming to your mental picture of what a paleontologist is, I'm probably not helping people to really understand the diversity that exists within the paleontological community, you know? There's so many different people with different backgrounds, different appearances, different attitudes, different specialties within fossil science. Yeah. If I fit the stereotype, sometimes I feel like I'm maybe not doing the best job as an ambassador to paleontology, but I can't help who I am, what I look like, all of that. So anyway.
This quarry has provided scientists with many dramatic fossil discoveries.
Critical Levels of Honk, thank you for the follow. Welcome. Yeah. Good stuff. Haruka Kitsune, thank you for being here. Welcome to Paleontology. Hello. Yeah. And Honey Koi Koya, thank you for the follow too. Welcome. Yeah.
Dinosaurs came in all shapes and sizes.
They did, and so do paleontologists. Haruka Kitsune, thank you for the follow. Welcome to Paleontology. Oh, and Nero Crab says, no, you're not the perfect image of a paleontologist. You're what I would describe as a cool. As in, that cool uncle everyone loves to visit for his field stories. I know the field is as diverse as the species better than that. Nero Crab, thank you. Alright, I appreciate you saying. But yeah. And Rakadactylus says, conversely, being in alignment with stereotypical portrayals of scientists gives you an edge when communicating and educating about the wider diversity of people who do paleontology. I suppose that's true, Reiko. Yeah, I don't know. There's a certain, like, privilege that is afforded from that, and I want to use that for good, you know? So I want to be conscious of that. Yeah, you know. Yeah. Anyhow, thanks, Reiko, yeah. Here, what were we talking about before this? Oh yeah, the Kosai Science Center dinosaurs. Look at this. Wow, they've got a lot of stuff. This might be a traveling exhibit. I think I may have seen this one before. Yeah, big Tyrannosaurus skeleton. I think this might be AMNH 5027. Might be a cast of the American Museum Tyrannosaurus. So this one, I have seen this before. This is super cool. This is like a juvenile Tyrannosaurus skeleton. And, you know, it's all cast and sculpts. But, yeah, it walks. So you can kind of... Actually, it looks like it's not supposed to be a juvenile. It's just kind of juvenile coded. The posture is like very juvenile T-Rex. The arms are big like a juvenile too. But anyway, it walks and basically like shows you what's going on in the skeleton as the animal is kind of going through its natural posture as it's walking. It's really cool stuff. Yeah. Here, I'll see if I can find you a video of that, because it's really neat. There we go. And they had all the life stages, which is awesome. You know, this is something that we talk about all the time on this channel, is this idea of ontogeny. So as dinosaurs, individual dinosaurs were growing and developing and maturing, they change a tremendous amount. To the point where they fooled a lot of paleontologists in the past who, you know, dug up a juvenile. Ontogeny. And they said it looks so different from an adult. It's got to be a different species. There's no way these are the same animal. But no. Ontogeny. Sometimes they are the same animal. So Triceratops changes a tremendous amount. Tyrannosaurus did too. Here, let's see if I can find you a clip. Oh yeah, this is cool. Here. Here, give me just a second. Let me get this set up for viewing properly. There we go. Yeah, going from a small juvenile into a larger juvenile into a subadult, and you'll see they reach a plateau at a certain point and they just bulk up. And then you get your adult Tyrannosaurus morphology, where it's this huge hulking predator. Or maybe, frankly, maybe mostly scavenger when they reach that full adult size. It's, if they're able to find enough food just by scavenging, there's no reason they wouldn't have done that, you know? Wouldn't have been picky animals. But yeah. Ontogeny. Anyway, understanding ontogeny, understanding the growth and development of dinosaurs is extraordinarily important. You don't understand them as living animals unless you understand their ontogeny. Crucially important. And Ziff says, if you made ontogeny posters for school, I'd buy one. Thanks, Ziff. Yeah. I haven't done posters before, but I did buttons for the Society of Vertebrate Paleontology meeting back in 2013. Here's the Triceratops one that I did. And I did a Pachycephalosaurus one. There. And then a Tyrannosaurus one. Right here. It was a lot of fun. And the texture that you see behind, it was, of course, dinosaur internal bone texture. Those are bone cells. The way that we can tell if a dinosaur was a juvenile or an adult, really the only surefire way of being able to say for certain, is to cut the bones open and then look at the growth rings. Look at the texture of the bone. Look for these, what we call lines of arrested growth, or lags in there. Almost like looking at a tree stump and counting the rings to figure out how old the tree was when it was cut down. We do the same thing with dinosaur bone. Histology is what it's called. And sometimes it surprises you. Something you were sure was, you know, an adult of a different species. It turns out, nope. It's just a juvenile of a species you already know about. And if it's the other way around, then histology can tell you that too, you know? Really, really important. Anyhow. Yeah. And need them. We'll see. If I end up doing a merch drop at some point this year, I'll see if maybe I can throw some buttons in there just as like a gift or something. We'll see. Yeah.
I'm interested in your island. It's got nothing to do with oil. I'm a paleontologist.
Zushi Cat, thank you for the follow. Welcome. Good to have you here. Kudali says you have more ideas for shirts and stickers? I've got so many ideas for shirts and stickers, absolutely. So yeah, and not enamel pins, MLS, but pin back buttons. You know, the round buttons. I have a button press, and yeah, so I I can make these by hand, you know? That's part of how I used to make a living when I was in Montana. I used to provide merchandise to different museums around the state. And for a while, I was able to pay the bills doing that. So, yeah. And hibiscus, yeah, it's for, you know, the rings like that, the annual rings on trees it's for temperate habitats where you've got strong seasonality. But yeah. Anyway, yeah, salamander. We'll see. I'd love to do some merch at some point this year, but I have so many other things going on. It's difficult to find time for the stuff that I do right now, let alone have other projects. But we'll see. There's a big conference, the big conference every year. The Society of Vertebrate Paleontology annual meeting is going to be in Birmingham, UK this year, and it is going to be expensive for me to get there. We might end up doing some merch streams and some merch drops to help me raise money so that I can afford to go. So yeah, it might be... It might be something like, I don't know, mid-August or something like that. Maybe we'll do some merch. It might work out then. We'll see. Anywho, yeah. But yeah, and Nemo Lock. Hey, I appreciate the thought. I can't make any promises about appearing on anybody's streams or anything like that. I'm already super busy as things are. It's exhausting, frankly. But I appreciate your enthusiasm and that you think of me for that, you know? So yeah. Anywho. Overbooked for 2025. In a lot of ways, yeah, Lenina, it's definitely. But yeah, and thank you, Nero Crab. I appreciate it. Yeah. Here, before I forget. Oh, and thank you for all of the engagement here, everybody, on Blue Sky. This is funny. Yeah. Seth Finnegan, who's over in Berkeley. He's a paleontologist at the University of California Museum of Paleontology and the Department of Integrated Biology at Berkeley posted this glyptodont. Love this glyptodont reconstruction in the excellent Tokushima Prefectural Museum in Japan, presumably. It's the first one I've seen that manages to capture the very specific derpy look of an actual armadillo. And I was so smitten by this that I took an up-close screenshot and reposted it. Look at those eyes. This is very much not a dinosaur for anybody who is new here. This is a mammal, you know? This is from long after the extinction of the dinosaurs, except for birds. This is a critter that lived very recently as compared with Mesozoic dinosaurs. But yeah. Anyhow. And very funny, Nero Crab. But yeah, Papa Meow Meow says, ladies. Yeah. And are armadillos mammals? 1000% Amalith, yeah. Yeah. And Bondo Latour, we do have evidence that, not early hominids, but humans, Homo sapiens, interacted with and hunted glyptodonts. When humans made their way across the Bering Land Bridge, or across the Bering Strait, I should say, into North America and then into South America, they encountered glyptodonts and may have hunted them to extinction. That might be why we don't have glyptodonts anymore. But yeah, here, let's look up armadillos on our Tree of Life, since we've got new people here. Anytime we've got a bunch of new folks, I like to emphasize a particular point that is crucially important. If you don't understand this point, you do not understand biology. This is like the fundamental idea in biology, is this idea of common descent. And as far as we know, all living things on Earth, and all extinct things for that matter, all life forms are descended from a single common ancestor, probably about 3 or 4 billion years ago. That's why all living things have DNA on our planet. If we ever find life elsewhere in the universe, it might not have DNA. It won't have DNA, probably in the same way that life forms here do. All life on Earth, as far as we can tell, came from the same ancestor. About 3 or 4 billion years ago. And so the way that we classify living things as scientists is based on their ancestry, based on what they're related to. When we say that different critters are related, we mean that they are literally related. Like they come from an ancestor in the same way that you and your cousins, if you have cousins, are related. You share a common ancestor. You've got the same grandparents, or at least one same grandparent. Mini Pie here and me are related too. Not super closely, but pretty closely in the grand scheme of things. Let me show you. Actually, let's grab that page. This works better in Firefox. Let's do that there.
Tradoon.
There we go. Interactive Tree of Life. So, let's find... cats and people. Cats. There we go. So a domestic cat, like Mini Pie here, and a human being, like me, Homo sapiens, we last shared a common ancestor about 95 million years ago. This is what our common ancestor would have looked like. Some little shrew-like type mammal. One of the first placental mammals. Around... Well, yeah, this would be like our 21 millionth great-grandparent. Does that make sense? So, yeah. And I don't think this got us to... Yep. Here. This didn't get us to armadillo. Let's go back to all life here. And then we'll try, like, 7-banded armadillo. Because that's not what I was looking for. I'm not sure what kind of critter that was. 7-banded armadillo. Oh, this will work. Yeah. There we go. Dasypus septemcinctus. Septemcinctus. Ugh. Anywho, there's our armadillos there. Common long-nosed armadillo. That's probably the one that you get down in Texas and surrounding environs. Actually, I'm not sure which of these is. But yeah, armadillos right there. So the common ancestor of all these guys lived about 40.2 million years ago. That's probably based on molecular data, comparing their DNA and figuring out when they last shared a common ancestor. Armadillos are most closely related to, among living animals, anteaters and sloths. These are all xenarthran mammals. Xenarthran means like strange wrist bone because they've got really weird wrist bones. And the glyptodont is a member of this group too. I think it might actually be part of the armadillo family per se. But yeah, anyway. These guys are very much mammals. Armadillos, anteaters, and sloths are kind of atlantogenatin mammal, which are a kind of placental mammal, which are a kind of therian mammal, which are a kind of mammal. Make sense? Yeah. And critical levels of hunks is a pangolin part of their family. Not anymore. No, so pangolins. Pangolins are these guys. These were once thought to be xenarthrans or closely related to xenarthrans, because they do have a lot of similarities. These guys are sometimes called scaly anteaters, but they are not related to anteaters, it turns out. Molecular data and fossil evidence shows that they are probably more closely related to carnivorans, like minipie. They're probably just outside of carnivora proper. This is not a comment on their diet. Carnivora is it's a taxonomic group. Carnivorans are critters that have got these carnassial teeth in the back of their jaw for going on, taking meat off of bones and stuff like that. They've got these kind of almost scissor-like carnassial teeth, so like they're... Anyhow. Dogs and cats and weasels and otters and bears and sea lions and stuff, they've all got that same thing, that same kind of setup. And they're all carnivorans. They all share a common ancestor. Pangolins are just off to the side right there. So, yeah, they and the carnivorans probably split about 65 million years ago. So just after the extinction of the dinosaurs, during that big adaptive radiation, when, like, so many of these species on Earth died out. They were there to fill some of these niches and diversify wildly, and that's why we have cats and pangolins today, So yeah. You're so feisty, Mini Pie. You're so feisty right now. Do you want some treats? Is that what you want? Yeah, okay. Alright, let's make that happen. Yeah. And love pangolins for an animal? Yeah. I don't know how the scheduling is going to work out this year, but we'll probably have World Pangolin Day live on stream at some point in February. I think it's like the third Saturday in February or something. So we'll see if we can do that. Ooh, that's the good stuff. That's what you came here for. Yeah. Look at all those treats. My goodness, that's too many. You're not going to eat all those. Let me take the junk food ones out and leave you with the dental treats. There we go. Good stuff. Yeah. What do you think, Mini Pie? Yeah, crunch them up. You're good for your teeth. Good stuff. There you go, Galrox, yeah. Yeah. And Son of Austerlitz says, is there a good counter-argument against the missing link card theory critics resort to? Oh, you mean like the idea that, like, oh, well, no one's found the missing link between humans and human ancestors or something. There's a number of different ways that you could counter that. I mean, you could point out that it's incorrect, that we do have a ton of those fossils now, so that we've got kind of smooth gradations in a lot of these places, more or less smooth, Look, there's more. You gonna eat that? Hey. Ooh, there you go. Clean it up, please. Thank you. Yeah. The thing is, when we're talking about, this is why I don't like the term missing link, because when you find it, then it isn't missing anymore. Say you're trying to find, I don't know. You're trying to find the links between species A and species Z. Say you find species M right in the middle. Like, wow. Found this cool link that was missing. This is a member of this lineage. I'm oversimplifying here, kind of assuming an anagenetic lineage, but we're not going to get too into the weeds on that. Once you do end up finding that, then people who are opposed to the idea of evolution, they'll go, well, first you had one missing link But now that you found it, now there's 2 openings. Now there's 2 missing links. And you go out, you find more fossils, the field advances, they'll publish on these things, and you find those, it's like, oh, well, now there's 4 missing links. Because there's gaps now in between. It's like the more fossils you find, the more people go on and on about those gaps. And after a while, it becomes obvious that, like, these people are not arguing in good faith. I'm not super familiar with the show Futurama, but this is a clip that people have shown me before, and I think it kind of illustrates that point. Yeah, so, you know, you get the idea. Yeah, have you seen that before, Petrodactylus? Not sure how well known that clip is, but yeah, there you go, Lydia. That's about right. I like to think. But yeah, you know. And critical levels of honk says, is it true that in another life I could have been a banana? You know, critical levels of honk? I say, don't sell yourself short. Doesn't have to be in another. You could be a banana right now if you want to be. The sky is the limit. Follow your dreams. Go for it, you know? Do it. Don't let your dreams be dreams. Yeah. Don't let your dreams be memes. There you go, Mayor Space, yeah. Anywho. And need to go to sleep. Go Nutty, thanks for being here. You get some good rest. I'll see you around. And Green User says, what are the 2 little skulls on your wall there? Oh, Heterodontosaurus and Lesothosaurus. There's some little 3D prints of early Ornithischian dinosaur skulls. These are from the early Jurassic of South Africa, both of them.
Observation. You couldn't see a thing. Conclusion. Dinosaurs.
Oh, yeah. Sleepy Lucarlio, thank you for the 2 months of support. I appreciate it. Thank you for the prime there. Good stuff. And Miko the Raccoon, thank you for gifting Riley. I appreciate that, Miko. Thank you, thank you.
In the channel.
Good stuff. Good stuff. Yeah. Yeah. Anywho, I've got Triassic and early Jurassic dinosaurs here in the office today because there was a new paper that just came out kind of hypothesizing about where dinosaurs would have first evolved, potentially. They're saying at mid-latitudes. We can take a look at that in a bit if you'd like to. But yeah. Anywho, sure I didn't miss any other questions here. And there you go, Bondo. Yeah, moving the goalpost, that is their MO oftentimes. Nero Crab, yes. Who was it who said that? Shoot. That phrase, that quote sounds familiar. No, somebody was asking about bananas, though. Like whether in another life they could have been a banana. Not quite, well, I'm not exactly sure what they're asking, but we as human beings are very, 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 very distantly related to bananas. Zoom into us on our tree of life here. Good old Homo sapiens right here. There we are. It's gonna take a while to get to bananas, but what is it? Banana. Oh, Musa. There we go. We're still on the same tree of life as bananas are, just not very close. So bananas also have DNA. They also originated from the same common ancestor that we did if you go back billions of years into the past. But bananas are a kind of flowering plant, a kind of angiosperm. And plants and animals once did come from the same ancestor, and they've since split. It depends who you ask what the exact figure is, but there is a percentage of our DNA that we share with bananas. There's a percentage of our DNA, there's a proportion of our genetic code that is identical between a human and a banana. There's a far, far, far greater percentage of that DNA that we as humans hold in common with, say, cats, or gibbons, or gorillas, or even chimps. It's like, depending on how you count it, like 99% similar between a human and a chimp. If you use the same metric, we'd probably have like, it'd be at least in the double digits, I think. At least in the double digits. It'd probably be in maybe even as high as 50% DNA in common between us and a banana. Because there's not a geneticist here, so I will, apologies if there are any geneticists watching. I will butcher this, but I'm hoping to get the basic idea across. A big portion of that genetic code just codes for things like, hey, this is how you make cells. This is how you produce different enzymes within the body or within the organism. You know, this is how you have a corporeal being, you know? A lot of the genetic code is coded for that super, super basic stuff. Those really important details, like whether or not you have limbs, or how many eyes you have, and, you know, a number of digits and all this other stuff, those are details compared to the, like, oh, do you have cells? Do you have a metabolism? Stuff like this, you know? So yeah, does that make sense? Yeah. An MLS is presumably the common ancestor didn't fossilize particularly well. No, it would have been a single-celled organism. So that common ancestor would not have fossilized, presumably. We can only kind of surmise what it would look like, and that, frankly, the details are, I think, in my estimation, not that important. You know? It was a single-celled organism. We know what those look like. It's as simple as a single-celled organism could possibly get, you know? So imagining all of the details there kind of doesn't matter to a certain extent, you know? It's like asking, maybe this is a bad analogy, but like, what is the simplest drawing that anybody could ever do? It's like, well, I guess it would be like a dot, or the tiniest little, you're just brushing the paper with the tip of your pencil, I guess. It's like there's not a lot of details to work out if we're talking about the simplest imaginable thing. Yeah. But yeah. Here, let's see if we can find a video to help kind of talk about this. And hello, Sweetie Pie. How are you doing? Sweetie Pie is stalking around the floor like a shark right now. And Hugin says, when did Afrotheria split off from other mammals. Here, let's look that up real quick. See you again. Good to see you, by the way. I hope you're having a good day. I want to say Afrotheria split off sometime in the Cretaceous before... Well, no. Yeah, probably sometime in the Cretaceous. I'm guessing like 90 million years ago. They split off from the rest of mammals. Afrotheria is the clade that includes manatees and elephants and sengis, elephant shrews, golden moles, aardvarks. Yeah. Afrotheria. So yeah, 84.2 million years ago is the estimate right here during the late Cretaceous. There you go. So yeah, all of these animals are each other's closest living relatives. Which is pretty cool. That a critter like a hyrax is closer to an elephant than it is to, like, way closer to an elephant than it is to, like, I don't know, a groundhog. This animal right here, far more closely related to an elephant than it is to a squirrel or a groundhog or something like that, some kind of rodent, you know? Yeah. Anyway, hyraxes are really neat. Yeah. But yeah. Yeah. And Critical Levels of Honk says, why did so many crazy looking critters come out of the Cambrian period? I think you've got to have diversification happening at some point, and it just kind of happened then. Some of that sudden explosion of diversity, though, I think is overblown. Because, A, it turns out we find early representatives of some of these groups, so it was more of a gradual development of these different lineages, rather than just, bam, it all happening at once. Another thing, too, is that during the Cambrian explosion... Here. You had all of these cool, wacky critters just kind of emerging around the same time. It turns out a lot of them didn't emerge at the same time. Some of them have ancestries that go back further. So it was a more gradualistic thing than is often portrayed. But also, it was around this time that a lot of different critters started to develop hard parts. And so they became so much more easy to fossilize. If you're a soft-bodied organism, then it's much more difficult to be preserved as a fossil in the first place. You know, if you're like a worm or something like that with no hard parts, it's much tougher to have your body get preserved and not just completely rot away if you don't have any hard parts. If you've got a nice shell or something, that shell is going to stick around long after you're dead, and you stand a higher likelihood of becoming a fossil. You know what I mean? Yeah. What do you think, sweetie pie? Oh, are you bored by this conversation? I'm sorry. Would you find it more interesting if you were presented with some treats? What do you think? Got key grip sweetie pie here. Or camera operator? Sweetie pie. Yeah. Yeah. You doing some cinematography? Yeah? Yeah. What do you think? Does that look good? Okay, sweetie. Let's get you some treats. Come here. Ooh, you want the last of them out of the bag? Oh. Whoa, look at that smorgasbord. Look at those. Wow. Holy cow. Good stuff. Look at that, just a giant pile of treats. You gonna be able to eat all of those? What do you think? She's gonna try. She's gonna try. Anywho, I hope that makes sense, what we're talking about here, you know? again, I work on dinosaurs. Dinosaurs are what I specialize in. So a lot of this stuff, I can only really speak on in the broadest terms. When we're talking about common ancestry, last universal common ancestor, all of that stuff. But here's a neat video talking about that. Oh, no, this is not the one I thought it was. Let's see. This might be neat, though. Here, let's take a look at this.
Here's an incredible thought. You are the living ancestor of an unbroken chain of lives, stretching from you, through your mother and your grandmother, all the way back through the complete history of life on planet Earth to the very first life forms that appeared around 4 billion years ago.
How cool is that? I mean, holy cow. This is the sort of thing that I get excited about. You know, this is the kind of perspective that paleontology gives us. It's just beautiful.
Isn't that mind-blowing?
Yeah.
And the fact that you exist proves that this is true. Combined, of course, with our understanding of evolutionary history, where life on Earth has evolved into more complex forms over time due to different pressures from the environment and competition with other animals. Try and imagine all of your direct ancestors, all of those individual creatures that managed to survive birth.
Critical levels of hunk says, gosh, I never thought about that. Dang, now I feel small. That's the thing. In the same way that you can look up into the night sky at these stars that are thousands, millions of miles away, you can feel that kind of wonderful feeling of smallness. In the same way, you can look up into space, you can also look down into time. If you think about the vast and storied history of life on Earth, it's incredible. You can get that same wonderful feeling of smallness, but it's also, I think, in some ways kind of counter to that feeling of intense, like, distance and loneliness that some people get when they look up into the night sky. When we look into the ancient past, we think about all of those generations that came before us, it's a remarkable feeling of connection, you know? Especially when you realize that all living things on our planet share a common ancestor. They all came from the same place, you know?
All of those individual creatures that managed to survive birth, avoided being eaten or dying from disease, and getting enough food for long enough so that they could rear their young, over and over and over again until it all ended up with you. Every single life form in that chain managed to do that.
Pretty cool.
Now, I've oversimplified a little bit by just talking about a chain of life. In reality, there's a big web of lives going back into the past. But just to keep things simple, you can think about a chain of all of your ancestral mums. Imagine your mum, and then her mum, and her mum, and so on, going back through all of human civilization, back to when we were human hunter-gatherers in Africa. Direct ancestors of yours survived a supervolcano that dimmed the sun for 6 whole years, and glacial periods where the earth turned cold and dry, and the total global population of humans is estimated to have been about 10,000 people, and may have been even lower.
Yeah, we know this because there's a big genetic bottleneck, where we know that human population dipped to a pretty small number at one point, because human beings on our planet are remarkably genetically similar to one another. There's not a lot of genetic diversity among human beings all over the planet. People that you might think look very, very different from one another are actually pretty darn closely related, in the sense that, like, we share a tremendous amount of even those, like, relatively unique parts of our DNA. You know, the stuff that makes us human, that percentage of our DNA that's unique to humans, that is fairly uniform across all of humanity. You compare that to other species where there's, like, a tremendous amount of genetic diversity, different genes, like, even among populations that, you know, we might think that they all look pretty darn similar, maybe even close to identical, and yet there's more genetic diversity there than there is across all of humanity in a lot of these cases.
Estimated to have been about 10,000 people, and may have been even lower. Then back through the ages when our ancestors were hunted by saber-toothed cats in the savannas of Africa and lived in a world shared with giant gorilla horses and giant sloths the size.
They forgot the C. It's Calicotherium. There should be a C right there. Is there an H? Calicotherium. I think there is. Yeah, there is. Calicotheriums, these guys. Yeah. So these are horse relatives. They're perissodactyls, which is really neat. So they're related to like horses and rhinos and stuff. Yeah, cool critters. They're not related to sloths. Very distantly related. Like they're both mammals, but they're holy cow, they're super, super different from each other, even though they look similar. Probably because they evolved in a similar direction to do a similar job, but they've got different ancestries, you know?
Of elephants. Then, through our common ancestors with
and
the
that could be
great apes and
Carnotaurus,
the
yeah.
monkeys,
Could have been the
through
Toba
to the
eruption.
animals that survived the impact of the meteorite that killed off most of the dinosaurs.
Yeah.
The last common ancestor of humans and mice was 100 million years ago, and all of the mammals, including you, came from the first mammals, which were small, shrew-like animals.
Yeah, like Morganucodon right there. I've got a 3D print of Morganucodon right over here. I actually had to print it like larger than actual size because my printer doesn't, I don't know, the nozzle that I have, the 0.8mm nozzle, is just not fine enough to print this critter as small as it should be. This is from the early Jurassic. These are what our ancestors looked like toward the beginning of the age of dinosaurs. And mammals mostly stayed very small, inconspicuous creatures throughout the age of dinosaurs. It's only after that asteroid hit they really diversified into the cats and bats and rats and goats and giraffes and whales and etc. that we have today. Dr. Irrefutable says that looks a lot like a rat. It would have had maybe slightly similar habits to a rat, I guess. It's a small critter doing its thing in the underbrush, probably doing a lot of hiding from dinosaurs, maybe eating bugs. But yeah, it looked kind of like a rat or a vole or a shrew, perhaps. Yeah, there's a really lovely reconstruction of it right here. This is kind of the one that I was trying to replicate. Morganucodon. Morganucodon, I thought it was called. And then I actually heard some mammal paleontologists talking about it. They pronounce it Morganucodon. So there you go, Morganucodon. But, yeah, this is 2 times actual. This is nice. Small animal. Small animal. Yeah. So, yeah. Anyway.
Ancestor of humans and mice was 100 million years ago, and all of the mammals, including you, came from the first mammals, which were small, shrew-like animals.
And he says shrew-like animals here, which is correct. They're not shrews. Shrews are a specific kind of later placental mammal. These guys are around before shrews were ever a thing. It might look like a shrew, but it looks like a shrew in the same way that, well, in the same way that that sloth looked like a Calicotherium we talked about a few minutes ago. They're not actually related. This animal's not closely... It is possibly an ancestor of shrews, but it's also in the same way an ancestor of whales and giraffes and bats and horses, even though it doesn't look like any of those. But it is a, small mammal, so people are going to say it looks mouse or shrew-like. You know? Yeah. Yeah.
Then back through earlier animals to the common ancestor with dinosaurs
and thank you, Appeared, for the follow. Welcome to Paleontologizing. Purgatorius looking to fight a guy right here, yeah. Yeah, Purgatorius. He's like, yeah, come at me. Mess you up. I'll bite your knees.
Then back through earlier animals to the common ancestor with dinosaurs and modern reptiles and birds.
Yep.
You're related to the first reptiles, which evolved from amphibians, which evolved from fish, and they came from even earlier vertebrates.
Yes,
and
indeed.
These came from the first animals that have a heart and circulatory system. And then worms with the first bilateral symmetry, to the first animals with nerves and muscles, to sponge-like creatures with the first different kinds of tissues. And before multicellular organisms were just single cells, complex cells, oxygen-breathing cells, first cells like bacteria, back to the very first life forms that turned from mixtures of chemicals to self-replicating molecules. You come from an unbroken chain of lives that span that unimaginable time. You're connected to eons and eons of creatures all fighting for survival and winning. And
fighting for survival, reproducing, minding their own business most of the time. I don't know. Sometimes it kind of irks me when they emphasize it, like, oh, fight, struggle for survival, fight. You know, that's not what most critters are doing most of the time. Most of the time, they're just chilling. You know. Yeah. But how cool is that? You know. All got that cosmic riz on us, says Nero Crab. Yeah. Yeah.
That span that unimaginable time. You're connected to eons and eons of creatures all fighting for survival and winning. And I think that's so incredible, it completely blows my mind. So what can we conclude from this amazing thought experiment?
What can we conclude from that? Before we see what he says, what do you think, Chad? What can we conclude from that? One of the main conclusions that I take is that we're connected to all other living things on Earth. We share kinship. Literally everything. We're part of this grand web of life, this grand pageant, I guess, of living things on our planet Earth. And we share common ancestry with everything. At varying distances, but still. It's pretty darn cool to feel that kind of connection. You know? Yeah. Life is amazing. I agree, Claire. It is. Yeah. Yeah, we are winning, chat, says Sasquatch. There you go. Yeah. Yeah. Both the best and worst of nature. I mean... Yeah, and knowing that, we can strive to be good and kind and considerate and wise. Yeah. And Gavrock says, my conclusion is that any of us being here at all is a massive chain of coincidences, and we're lucky that it all worked out. Absolutely, and we should be grateful for every breath that we have. 1,000,000%. It's... Here, I'll see if I can find you that clip again. With Stephen Jay Gould talking about this, talking about mammals, you know, our mammal ancestors. And how they managed to survive, seemingly by sheer luck, at the end of the age of dinosaurs. And that's why we're here now, you know. It really does kind of give you a different perspective, hopefully make you appreciate everything, you know? Where did that clip go? I don't even know if it's on here, actually. I don't know if I'm able to find it. That's okay. Anyhow, And Golganek says, I love that I'm related in some way to literally all life that is or ever has been on this world or ever will be. Yeah. Yeah, that's pretty cool. It's pretty darn cool. You know, to realize that we as human beings are related to bananas, to other flowering plants, to all eukaryotic life, to animals, vertebrates, amniotes, mammals, primates, apes, and then us. It's pretty darn cool. Feel kind of like feeling of oneness. You know? It's pretty special. And we're not Banana Sasquatch. No, don't take that conclusion away, because you know that that's not the case. But we do share some of that same juice with bananas, you know? There's a certain degree of our genetic code that is the same. That we both inherited from our common ancestor. You know? Yeah. Anyhow. Yeah. And I can see if I can take a look at that link, though. Oh boy. Reddit, we'll see what this is about. Oh, it's a mosasaur. Yeah. That's a mosasaur right there. Those are mosasaur jaws. Yeah. Yep, very lizardy looking. Yeah. Where are the other photos? How does this work? It won't let me go back. But yeah, that's 100% a mosasaur. So, which brings us to an interesting kind of confluence with something that we're talking about right here anyway. So I can find this one that has the subtitles. Cross your fingers that it's here.
Attached to the floor.
Nope, no subtitles on that one. That's not it either. Subtitles.
The following presentation is from PBS Home.
Here we go.
Once, 70 million years ago, this was the bottom of a sea, a warm sea, and here limestone was formed. For centuries, the people of Maastricht quarried this limestone for buildings,
in the Netherlands.
burrowing
Maastricht,
into the rocks to
in
create
Holland.
a vast warren of caves. It was the year 1770. Quarrymen, working 500 yards from the entrance of one of
Oh, and this is not a swimming dinosaur Sasquatch. This is a marine reptile, like we're going to see here. A mosasaur, which is not a dinosaur, and I'll tell you why in a little bit.
unearthed something that made the rest of the crew lay down their tools and gather around in amazement. Over the years, they'd often dug up chips of bone, fragments of skeletons, but never anything so mysterious. They knew someone who would pay good money for their discovery, a retired military surgeon called Dr. Hoffman.
And so this is at a time, you can see by the torches and everything, this is in what? It's the late 1600s or 1700s? I forget. But this is at a time, and this would be 1700s. Nobody knew anything about the history of life on Earth. Everyone assumed that the Earth was young, you know, because they basically treated the Bible like it was a geology textbook in a lot of cases. They're like, well, you know, if you add up all of the begats in the Bible, then that, you know, that tells you how old the Earth is. It's like, there wasn't a really sophisticated understanding of, frankly, of science back then. And so people just kind of assumed, like, oh yeah, the Earth is maybe a few thousand years old, if that, you know, and humans have been around since, you know, since the beginning, since the first week, of course. And then later on, 17 and 1800s, people, well, all over the world, but people in Europe especially here, started finding fossils and asking questions about them and drawing them and writing about them and talking about them. And it was the first time that fossils started to be really studied in an organized, systemic way that has since been recorded and carried forth into the present, you know? And this is a big deal, you know? Like, there were a lot of people at the time who would have been very superstitious about this kind of thing. They're like, why are you digging up the bones of these demons and dragons and stuff? And, you know, why are you disturbing these things that are sleeping in the earth? You know, people didn't get it back then. It's kind of scary that we're seeing sort of the reemergence of this that kind of superstition in a lot of places on the internet nowadays. But it's just a discussion for another time.
Dr. Hoffman was one of the first in a long line of professional and amateur scientists and bone hunters
Oh, there you
who
go,
have been
critical
fascinated by these secrets that the Earth yields up.
I
so
know what that's
grudgingly.
like. I've done something very similar before, yeah.
Hoffman hurried over to the quarry.
And QuakeCat says it's hard to fathom there are still folks out there who still believe the Earth is 6,000 years old. QuakeCat, they run the U.S. government. Like, I'm not kidding. Not only do these people walk among us, they are some of the most powerful people in the world. They run the country, you know? Which is, I think, why it's so important to talk about science, you know? Yeah.
And was shown something he had never seen before. It appeared to be an enormous jawbone.
So there we go. That's exactly that Reddit post. The jaws there are of a mosasaur, as plain as day. Really similar morphology to the lower jaws. It's the dennary right there, and there's those dennary teeth sticking out. That person on Reddit, they found a mosasaur. And so at the time,
immediately,
this was considered a curiosity. Like, oh, what is this incredible thing? Some of the people who were excavating this probably thought, oh, you know, those aren't actual bones. It's just some trick of the earth or something like that. The idea that fossils were a real thing was almost kind of a new idea. A lot of people thought, oh, you know, it's got to be some, not quite an optical illusion, but, you know, it's the earth playing a trick on us. It's God pulling a prank or something. And after a while, with, you know, more and more fossils being found and being studied in a systemic way by people that we would today call scientists, it started to become clear, like, nope, these are the remains of ancient living things. Those look like teeth because they are teeth. And so a really early kind of stage in paleontology, the beginning of the science of paleontology, the study of fossils, was regular people discovering things like this in quarries and stone pits and mines, keeping them as curiosities, and then them finding their ways into the hands of naturalists who wanted to study them, comparing them to the bones of living animals, what we call comparative anatomy.
He bought it immediately. "25 years later, the jaw of the monster attracted the attention of the French Revolutionary Army, who occupied Maastricht in 1795. They claimed the jawbone for France, where to this day
looted
it
it,
reposes
really.
in the National Museum of Natural History in Paris. Soon after the French Revolution, the National Museum was the scene of another revolution.
Yep.
This one led by a celebrated professional scientist,
Cuvier.
Georges Cuvier.
Cuvier was professor of comparative anatomy, which was a booming branch of science at that time.
So this was, I don't know, if we trace back modern science, like the threads kind of go back to this time. There are other times earlier, prior to this, where I'm sure people have looked at fossils, they've looked at the bones of animals, and they've puzzled about them, and they've maybe even written stuff down, but none of that stuff has survived into the present in the way that this has. You can draw a continuous thread from paleontologists today through their various mentors and academic advisors and stuff. You can trace that pedigree, that lineage backward to people like Cuvier and Huxley and Darwin and Owen and Mantell and Buckland. These early kind of like pioneers in the field of fossil science and biology. Their legacy continues into the present. It's a continuous history that goes from then until now. So that's why it's important. Cuvier himself was, I think, in a lot of ways, probably not as brilliant as he's often been given credit for. But I don't know. We'll talk about this later too. We usually do a special stream on the anniversary of Cuvier's death. Because I think his birthday we would do his birth, but I think it's usually while I'm out in the field. I want to say it's in the summer. It might even be in August. But anyhow, Cuvier was one of these people who started to figure this out. He was really asking those hard questions, and he wanted to figure out what was true, which was important. It's kind of this Enlightenment ideal of like, let's try and figure out what's real and what's true, regardless of what the other people in our society want us to think. If we want to actually know what's what, we've got to actually study things. We've got to test ideas. We need evidence. And to a certain extent, Cuvier was all about that.
Professional scientist, Georges Cuvier.
Cuvier was professor of comparative anatomy, which was a booming branch of science at that time.
Yep.
And it was the very best place in the world for him to be, because I think the museum there probably had a larger collection than anywhere else in the world of skeletons and skins and, to some extent, pickled guts and so on, of a whole range of living species from all around the world.
And so having a bunch of living species from all around the world at his disposal to study, you could look at them side by side, you can start to notice patterns, start to notice similarities, and start to wonder, why do certain creatures look more like other creatures? Why do they have similar structures? Actually studying animals in a detailed way, it's nuts to think about it now, but that was kind of a new idea back then, you know?
Like the other
In which museum? This is the museum in Paris, upstairs now.
Professors, he lived on the job. He had a house which went with the job, which was almost in the same grounds as
Sweet gig,
the
yeah.
museum and the Botanic Gardens. And the Botanic Gardens included, as it still does, a small zoo. So he had access to at least a small collection of living animals which he could study and see how they moved, how they put their anatomy to good use.
Yep.
So he was in a very good position to understand the relation between bones and muscles and sense organs and gut and everything else within a living creature and see how all those parts of the body contributed to a whole way of life.
Yep.
Cuvier had a theory. Huge bones had been found beneath the streets of Paris. They looked like elephant bones, except that they belonged to a creature that was clearly a different species, now called a mastodon.
And so at the time, everyone kind of assumed, because this was the kind of like socio-political religious viewpoint at the time. It's like, oh, well, you know, the natural world is divine and perfect in every single way. It is absolutely flawless, and it is supernatural. No living thing can ever go extinct. You know? All of these creatures that we share the planet with are, you know, the creations of God. And so they're not really, like, natural. They're supernatural in origin. And as a result, they will always be there. They can't change, and they certainly can't go extinct. The idea of living things changing over time, evolving, that was almost easier for people to believe at this time than the idea of creatures going extinct. The idea of living things just blinking out of existence, like a species just disappearing, that was like a heretical idea. And I'm sure it had been proposed earlier in time than Cuvier, and people had laughed at it, or people who proposed that might have been persecuted. But Cuvier, being, you know, this learned man of lofty standing in society, he could get away with saying this, pointing out, like, hey, it looks like these animals aren't walking around Paris anymore. And I don't think we'll find anything like this in the deepest jungles of South America or Africa or anything like that. You're not going to find a living mastodon anywhere, guys. He was able to say that without, you know, getting his head lopped off. Yeah.
Cuvier reasoned that these bones belonged to an animal that had become extinct.
And it was really the first time that there was a really good, pretty strong case for extinction.
Yep.
Then one
Those
day,
jaws
Cuvier
there.
turned his attention to the huge jawbone, the trophy from Maastricht.
And he compared it with living reptiles and concluded this time that it was an enormous marine lizard.
Yep, and he was right. Other people thought, oh, this has got to be a whale, it's a crocodile, it's surely a kind of crocodile that's still around today, and somehow the bones ended up in Holland. No, he's like, no, not only is it not a whale, and it's not a crocodile, it's a lizard. This is a giant ocean lizard that is now extinct, and Cuvier was correct. He was correct about that.
It opened the door to a past buried far deeper than anyone had imagined.
Yep, I mean, holy cow. Nowadays, we realize that these animals, mosasaurs, are these giant marine lizards that lived during the age of the dinosaurs. They were these top predators that ruled the oceans. They were the biggest carnivorous thing around. And it's kind of remarkable, actually, how quickly they adapted to life in the oceans, too. Because they were a fairly recent phenomenon in the late Cretaceous. Like, the heyday of the mosasaurs is just the late Cretaceous, and that's it. But during that span, during that, I don't know, 30 million years, 40 million years, something like that, they take over the planet. They become the dominant predators in oceanic ecosystems. And the more we learn about mosasaurs, the more remarkable it is how well adapted they were for life in the oceans. Early reconstructions of mosasaurs, you know, we're kind of like this. Very, very lizardy looking, and of course they are lizards. But yeah, it's like having like fringes along their backs. Kind of an eel-like tail. Here. Let's see. Yeah, kind of like this. Something like that. Almost like a mythical sea serpent or something. And nowadays... Oh, here we go. Beautiful. Superb. This is exactly what I'm trying to portray to you. So, Mosasaurus hoffmanni. That's the same one that we saw in the video. It's the one that Hoffman purchased and then Cuvier studied. Early on, it was thought to look something like this. In that kind of image of Mosasaurus and the other mosasaurs, this whole group, kind of stayed like this until basically like the 1960s, 1970s, and then today, this is almost a whale-like animal. It is a lizard, but it's remarkable how much our understanding of these animals has changed. Yeah. Here.
Nutrients driven up from the ocean floor.
This is from Prehistoric Planet from a couple years ago.
Plentiful supply of fish.
There's some plesiosaurs swimming around.
Streamlined bodies and 4 powerful flippers.
Watch out, plesiosaurs.
Elasmosaurs great maneuverability.
Elasmosaurs are a kind of plesiosaur.
But their daily feeding forays make their movements predictable for an intelligent and patient hunter.
Uh-oh. X-Ray Blacksmith, how are you doing? Welcome to Paleontology.
Mosasaurus is an ambush predator. This enormous animal uses its huge tail to accelerate with astonishing speed.
Watch this. Crazy fast.
This time, unlucky. In fact, most hunts fail. But with so many elasmosaurs living here, it's not long before there is another opportunity.
There again. Oh man. Imagine scuba diving, and then you just see this thing emerge from behind a reef. Like, oh no.
Camouflaged against the dark canyon floor, the mosasaur can approach unseen, waiting for a young, inexperienced individual, the ideal victim.
Uh-oh.
Mosasaurus can strike their prey with such force that the impact alone can kill. It's an attack so swift, the elasmosaur almost certainly never saw it coming.
So yeah. Our modern picture of mosasaur is very, very different. From those old, like, sea serpent-like ones. In fact, this reproduction right here from PNSO almost looks cetacean. It almost looks like a whale, you know? But it's a lizard. Really cool. Not only did they have that fishy fluke at the end of the tail, but many mosasaurs actually seem to have had kind of a dorsal fin. And because there's no bones in that, we didn't realize that until very recently. So again, going from this to a lot of these guys probably had a dorsal fin. Which is crazy to think of a lizard with a dorsal fin. And a fishy, fluky tail like that, but there you go. So again, these guys are lizards. So they're part of Squamata, this group here. And hydrodynamics works convergence? Exactly, Golganek, yeah. Squamata, the lizards and snakes. Mosasaurs are probably part of this group, Varanoidea. We're still trying to figure out exactly where mosasaurs lie on the family tree of lizards. We know that they're lizards, but I think there's a general consensus that they're in or around Varanoidea, the varanid lizards, the monitor lizards, like this. Komodo dragons are the most famous kind of monitor lizard. Yeah. And hey, Medibs, how are you doing? Hello. Well, good to have you here. Yeah. Gameverse Man says, looks like a shark with a gator head. I mean, kind of, yeah. Yeah. That's kind of how you can think of mosasaurs, in a way. Or think about, like, you know, like a long stretched out shark with a Komodo dragon head. Can we get some Komodo emotes going in the chat? I think tegus are scarier. Tegus don't really... Are they carnivorous, Barnsdale? I know varanids can and do kill and eat people. I don't think tegus do. But yeah. Nice, Lenina, Petrodactylus, Gary, and Callus. Yeah. Those Komodo emotes. Good stuff. So yeah, pretty cool to think about how much our understanding of this group of animals has changed. And at the same time, it's like the more things change, the more they stay the same. Not in terms of our understanding of the history of life on Earth, but in terms of the things themselves. Before, we thought mosasaurs being lizards, oh, it's a big lizardy, sea serpent-y type thing. It's like, nope, it would have looked a lot more like a whale than you would have imagined. Same with ichthyosaurs. Same with plesiosaurs to a certain extent. It kind of shows this idea of convergent evolution. And for some of you, this might be kind of a new concept. But when you get different kinds of critters that are put under the same kinds of pressures, they can develop remarkably similar morphologies. So they can end up looking really similar, even though they're not, you know? So here, let's see if trying to find you a decent video on convergent evolution. I'm trying to figure out which of these is going to be best. Let's see if old Ricky Docky here has got, if this is any good. I think it is. I think I've seen this before.
Animals resemble inedible objects. Designoid objects sometimes resemble other designoid objects for other reasons, because they're doing the same job.
So, if there's anybody from the UK, tell me if this is a thing. I think it's a thing. This is like a Christmas lecture. Is that a thing in the UK? Where, like, you know, a scientist might get a TV slot around the holidays in order to be able to, in order to be able to communicate some ideas to the public.
And this is called convergent.
Rousey says, yep. And Niffler says, nope. Red Crayon Bennett says, I'm not sure. But I'm not sure if it still is, but it definitely was. Okay.
This is an ordinary hedgehog. That is nothing whatever to do with a hedgehog.
That's an echidna.
Superficially, it looks like it.
Yeah.
That is a spiny anteater. It is a mammal, but you might...
It's not an anteater, though. It's an echidna. Yeah.
Say only just a mammal. It's an egg-laying mammal, a very primitive mammal from Australia and New Guinea.
Yep.
As a matter of fact, its way of life is not that close to a hedgehog's way of life. This is an anteater, whereas hedgehogs eat more general things, insects and worms and things. But both of them gain protection from having spiny skins. And so they both superficially
Christmas lecture every year. Very cool, Papa Mewing.
An example of convergent evolution. An even better example of convergent evolution is the so-called marsupial wolf.
Critical level savant says, what did they do to my boys Knuckles and Sonic, my poor lads? No. They're just sleeping, Critical. They're just sleeping. Don't worry about it. You know? They were very tired. They did a lot of running and eating gold rings, right? Isn't that how those games work? They ate so many gold rings that they're just, you know, they're taking a rest.
And so they both superficially look very alike. An example of convergent evolution. An even better example of convergent evolution is the so-called marsupial wolf.
Yeah, the Tasmanian tiger, the thylacine. Oh boy, they've got a taxidermied one.
Now, if you saw that going along on a lead down the street, you would think it...
You'd think... Oh, Grandma, what bad taxidermy you have.
Now, if you saw that going along on a lead down the street, you would think it was a dog. A slightly odd sort of dog, perhaps. There aren't many dogs that have quite that structure at the tail end.
But yeah, no, it kind of reminds me, shoot, there's, in my neighborhood, there's a funny thing that I've seen many times. Like, the first time I had to do a double take, I'm like, am I hallucinating here? You know, I love to go on walks and, yeah, like, I encounter all different kinds of people in the neighborhood. And there's this lady walking a pretty big dog. And, you know, I looked and like, that's a big dog. That's not a dog. It was a small horse. Walking down in an urban neighborhood. There's this lady walking this little pony. It was like about the size of a Great Dane. So very small for a horse, but it would have been very big for a dog. And, yeah, and I remember telling Ios and Lordy, like, there was a lady walking a horse around.
This is the
like,
horizon, which marks the extinction of the dinosaurs. Below this level, and out
Dyson Dinosaur.
Dinosaur fossils.
Thank you
Above
for the
this
raid.
level, on these rocks, there are no dinosaur fossils. So I'm actually standing on the level that marks the extinction of the dinosaurs.
Thank you, Dyson Dinosaur, for the raid. I really appreciate it.
Stumbled below that level.
Hello there to you, too.
Dinosaurs.
Filippo Bertozzo is Dyson Dinosaur. He is also a dinosaur paleontologist who streams here on Twitch, and you should absolutely follow him if you're interested in dinosaurs, or if you'd like to follow another paleontologist. He usually streams in Italian, but on weekends he streams in English. He does special paleontology streams. He's also into tabletop games, so if you like dice and or dungeons and or dragons and that whole kind of milieu, go follow Dice and Dinosaur right now. Filippo, I hope you had a wonderful stream. It's good to have you here. This time about your new paper. Yes, Dice and Dinosaur. Very cool. Very, very cool. I haven't seen any press about that yet. I'm excited. I'm excited to read it. Is it published now or is it a preprint? Let me know. And Rocket Sage, how are you doing? Hello. We've got a geologist here in the chat too. Rocket Sage, it's good to see you. Welcome, welcome, Sage. Yeah. Oh, +1, all out. Excellent. And 3D models free for download and print. Oh boy. Filippo, I'm tempted to ask if you would want to do an interview on my channel this week about your new paper after I read it. But I'm not even sure I'm going to be streaming every day this week. I'm trying to get ready for this trip to North Dakota, where I'm going to be meeting up with Denver and Liz with some of my colleagues, and finally getting a manuscript submitted for publication. That's the goal. And then doing some streams from the museum. There's a lot of preparation I've got to do to get ready for that. But another paper in the next months for that. All right. Well. I look forward to it. Filippo. Holy cow. Good stuff. Good stuff. Yeah. Anywho. Thank you for the raid, Filippo. I appreciate it very much. And Sage, I hope you're doing well. It is good to see you. If anybody's not yet following Rocket Sage, she is a real-life geologist who streams here on Twitch. Her streams are very chill and very cool, and you can learn a lot about the study of the earth beneath us on Sage's channel. Good stuff. Yeah. A trip so you're not playing in the dirt in the winter, lol, says Madibs. Not in North Dakota, I'm not. No. It's gonna be... Well, let's see what the forecast is in Dickinson, North Dakota next week. Here we go. 10-day forecast. Monday, high of 6 degrees. Tuesday, high of 8 degrees. Those are the days I'm going to be streaming next week from North Dakota. Yeah. Oh, boy. Yeah. It's 32 degrees. Oh, it's positively warm there right now. But, man, is it going to be cold there on Monday and Tuesday. That's why we're going to do indoor streams. Yeah. And that's Fahrenheit, not Celsius. Oh, yeah. Yeah. What's 6 degrees Fahrenheit? It's what, like negative 10 degrees Celsius? Something like that? Yeah. Anyhow. Yeah. We were just trying to talk about convergent evolution, and I was telling a story about... Here we go. Here's old Richie Docky giving a public lecture on TV.
Of convergent evolution is the so-called marsupial wolf.
The thylacine, aka Tasmanian tiger.
Now, if you saw that going along on a lead down the street, you would think it was a dog.
Yeah, and I was right before we got that raid from Dice and Dinosaur, I was talking about all those times that I saw that lady walking a very small horse in my neighborhood. It would have been very large for a dog. I thought it was a dog at first glance. And nope, and it's like every time I see it, I always shout out to Ios and Lordy if they're around. Like, look, there's the horse walking by. Anyhow, this is also not a dog. A horse is actually more closely related to a dog than this animal is. This is a marsupial, for crying out loud. Here. Let's jump from monitor lizards out to all life. And then I'll show you dogs and how horses are closer to dogs then Tasmanian tigers are the dogs. So, Equus caballos, the Hoyers. There we go, right there. So, a horse is more closely related to a dog. Canis familiaris. There we go. So horse, dog, pretty short jump there, you know?
Let's protect our fossils, because if they're removed...
And El Kebabman...
Forever.
El Kebabman, thank you so much for the tier 1 sub. Welcome to the channel. Welcome to the community. Thank you for that pledge of ongoing support. I really appreciate it. Thank you for supporting Science Outreach here on Twitch. That's a big deal. Thank you, thank you. Yeah. Okay, so domestic dog to horse. You know, pretty close in the grand scheme of things. But we want to go out to the Thylacine. Oh, do they not have it on here? Because it's extinct now. But, let's just go to marsupials in general. You've got to go way over here to get to the marsupials. And the marsupial wolf, which is not a wolf, it's kind of marsupial. A pouched mammal. That's what this critter is. The Tasmanian tiger. Not the Tasmanian devil. Tasmanian tiger. These guys. The last of them died out in 1938. The very last one that we know of died in the Hobart Zoo in 1938. It was the very last one on the planet that we know of. Yeah. And here she is. See? What was her name? I forget. But she was the last of her kind. The Australian government actually put a bounty on their heads. Like, people were encouraged to hunt down and kill every single last one of them. Because they were thought to be a threat to sheep farmers. I don't know if they ever ate a single sheep, but yeah. The Australian government wanted them wiped out. And they got what they wanted. Beautiful animal. Much more closely related to a kangaroo or an opossum than to an actual wolf, but that's why they're called the marsupial wolf. They are marsupials, they are not wolves. Yeah. This is the very last one. So this is in 1933, I think 5 years before their ultimate extinction. Yeah. The last captive thylacine lived as an endling, the last known member of its species. That is the saddest thing in the world. An endling is the last known individual of a species. Once the endling dies, the species becomes extinct. That is one of the saddest words in the English language. Animal, a female, was captured by Elias Churchill with a snare trap and sold to the zoo in May 1936. Oh, so that footage must have been before 1936. Yeah. Anywho, yeah. Anywho, that's this animal. Right here. A thylacine. Tasmanian tiger. Marsupial wolf. This is an animal that, although it looks like a wolf, it is not closely related to wolves or dogs in any way. It's a marsupial.
Now, if you saw that going along on a lead down the street, you would think it was a dog. A slightly odd sort of dog, perhaps. There aren't many dogs that have quite that structure at the tail end. But you would think that that would not really be out of place at Crufts. But
I don't know what
this
Crufts
is not a dog. It has nothing whatever to do with dogs.
Yeah.
This is a marsupial. It's much more closely related to kangaroos and wombats and koalas. It's now, most unfortunately, extinct, only fairly recently extinct. It went extinct this century in Tasmania, went extinct some thousands of years ago on the mainland
Dog show that
of
makes sense.
Australia.
Yeah.
And
Yeah.
the reason it looks so like a dog is that it does the same job as a dog, or did the same job as a dog. It ran and hunted prey in the same sort of way as a dog does.
Yep.
And that's why it has the same shape as a dog.
I mean, he's trying to keep this kind of light and breezy for the audience there, like just, kind of surface level stuff. But to go into a little bit more detail about that, the reason why it looks so similar to a dog is it's got very similar evolutionary pressures exerted upon it. So, like, it's, like you said, doing the same job as a dog. It's running and hunting like a dog does in the wild. And so you've got the same evolutionary pressures, not just to look similar, but to be similar, They're both mammals. A kangaroo and a dog are both mammals. So they've got a lot of the same underlying architecture there that they inherited from their common ancestor. And the closer related you are, the easier it is to, like, evolve a similar kind of morphology. Because you're already starting off with most of the same parts. Like, your starting place is kind of closer, if that makes sense. So, that's why we see things like the kind of like saber-toothed cat body type evolve again and again and again. You get it in things like, the Machairodonts, the actual saber-toothed cats, like Smilodon. The so-called saber-toothed tiger. They're not actually tigers, but they're saber-toothed cats. It's kind of a more classic illustration of a saber-toothed cat right there. But you also get it in things like the Nimravids. So Nimravids are these cat-like mammals. They're not actually cats. They're related to cats, but they're not actually cats. And they often developed a, really similar kind of body shape, skull shape, everything else. They're doing a very similar job. These guys are pretty close to cats in the grand scheme of things, so it's really easy for them to evolve a similar kind of morphology. So there's a Nimravid right there. That's Dinictus. If you were to see this animal, you'd be like, oh yeah, dude, that's a cat. It's not actually a cat, though. It's from a different branch on the mammal family tree, but one that's still pretty close.
Developed protective armor to guard themselves from beasts like Tyrannosaurus rex.
And Feist, thank you for the 45 months. I appreciate that tremendously. Thank you, Feist. Thank you for the prime. We appreciate it. Yeah. We go a little bit further to other critters that look like cats but aren't cats and develop that same kind of saber-tooth morphology. We get things like Thylacosmilus. This looks kind of like a cat. Looks a lot like a cat to a lot of people. If you were to see this, you'd be like, who's that weird saber-toothed cat with the Jay Leno chin? But this is not a cat. This isn't even a carnivoran. This is a marsupial. And there are some reconstructions that kind of show that a bit more obviously. Like, I like this a lot. It almost feels kind of opossum-like, especially this one here, which is just kind of walking around like that, kind of like an opossum does. Yeah. Really cool critter. Again, it's developed that same kind of saber-tooth morphology. Because it is a four-legged mammal, and, you know, it's like that's just a design that works, and so you get this in different lineages. This one doesn't look as similar to the saber-toothed cat as the Nemrevit did. It's still pretty close, right? Let me show you another critter. Inostrancevia. This isn't even a mammal. It's like a mammal ancestor. And it's still got like a saber-tooth thing going on with it. These guys lived such a long time ago. They're before the first dinosaurs. This is back during the Permian period. We don't know if they had fur or not. We're not totally sure. But it is a saber-tooth kind of proto-mammal. How weird and cool is that? But again, if you've got the same basic kind of body plan, you're walking around on four legs, you've got a short neck and a largish head, you've got canine teeth, you might develop that same kind of morphology. You might turn into a saber-tooth, you know? That's like a viable pathway. And again, convergent evolution is a really cool thing where even if two creatures are not closely related, they can still develop the same morphologies. It's easier for them to do that, though, if they're starting off in a similar kind of spot. You know? Does that make sense? Yeah. But yeah. Yeah, like your opossum impression. Thank you, Uriah. Yeah. Anyway, let's finish out this video.
Okay, perhaps you could take it now, Bryson. Thank you. The structure inside also resembles that of a dog. This is a dog skull. And this is the skull of the Tasmanian wolf. It's a bit larger, but of course, the size of the skull will depend on how big the dog is anyway, and we could easily get a bigger dog skull than this. The only reliable way to tell that this is a marsupial and not a real dog is if you look underneath. Those two holes in the palate there give the game away. Those are the telltale clues that tell us that this is a marsupial and not a real dog.
Interesting. Do all marsupials
A real
have
dog doesn't have the same
I'm familiar with the
kind of
cranial
holes there.
morphology.
Well, that's convergent evolution among designoid objects. Designed objects, too, some...
Whoop. Designoid objects. I'm not sure what he means by that. But, yeah. And we see convergent evolution also between different groups of reptiles, for instance. Like, here's a mosasaur like we were talking about. So take a mental snapshot of this. Keep that in your mind. That's a mosasaur right there. You got it? Now, you would think this animal pretty closely related, right? Yeah, gotta be a close relative. Gotta be a close relative, right? No, not at all. This is an ichthyosaur. Symbospondylus lived, I think, in the late Triassic period. That mosasaur is from the late Cretaceous. They're separated by about, I don't know, well over 100 million years. They are not closely related at all. The mosasaur is a lizard. This guy is some sort of weird other reptile. We don't know exactly where the ichthyosaurs fit in on the reptile family tree, but we know for certain they are not lizards. Holy cow, are they not lizards? So, convergent evolution is a powerful thing. You can get this kind of... these kind of surprising, even shocking similarities between living things that are not closely related to one another. Yeah. And Son of Austerlitz says, didn't they feature this in the BBC documentary? Which one? There's been a lot. You talking about Walking with Dinosaurs, or actually Chased by Dinosaurs and Chased by Sea Monsters wasn't BBC, was it? It's like Sky TV? Sky TV? I don't know. I don't know a lot about British television. But yeah. Talking about Sea Monsters, says Crimson Carnotaurus. Yeah, probably. Symbispondylus was in that. Let's see if I can find that clip. And holy cow, Elka Bobman, thank you so much for the 5 gift subs. I appreciate that tremendously. Thank you, thank you.
LK Babman just changed
Wonderful.
things with those 5 gift subs.
I appreciate that. We are almost 1/10 of the way to our sub goal for the week. Thank you, Elka. I appreciate that. Keep up the great work. Love the channel. I appreciate that, Elka. Thank you very, very much. Thank you kindly. That's tremendous. And Mr. Delight, thank you for 29 months of support there. I really appreciate that, Mr. Delight. Thank you, thank you. Thanks for keeping me here online. Anyway, there's 5 very lucky chatters, Elka, that you just gave the gift of no ads to. So, I appreciate that. I really do. And I'm sure they appreciate it as well. There we go. Let me see if I can find the Symbispondylus clip. Let's see here. Where is that? Come on now. Haha. Here. This is from Nigel Marvin's Chased by Sea Monsters. Kind of whimsical. Like prehistoric nature documentary style show. That's Symbispondylus the ichthyosaur there. It is a lot of fun, Petrodactylus, yeah. Yeah. And it... it's goofy, you know, having a person there. But I think it's useful. Jogi, 19XX. Thanks for the follow. Welcome, welcome. Having a person there in the shot is... at least gives a sense of scale and certainly gives a sense of drama, too. Yeah, and this is not a lizard, Hibiscus. Not in the way that mosasaurs are. Mosasaurs are lizards. These guys are some other kind of reptile. I think we're still kind of figuring that out. Yeah. Oh, Symbispondylus, Ken. Symbispondylus. Yeah, Shastasaurus is a lot chunkier.
The next encounter takes Nigel back deeper into the past to meet the armored fish of the Devonian. Predators that are quite literally as hard as nails.
Yeah, Dunkleosteus. Other placoderm fishes. Like somebody was mentioning in the chat earlier. Anyway, here's a link to this if you want to watch it on YouTube. Good stuff. Dunk was a chunk, yeah, especially recently, after it's been downsized. Shrunkleosteus. Yeah. So in older reconstructions, you see, yeah, like this, enormous armored fish. Like that would have been the size of a white shark or bigger. Like that. But I guess it should be Dunkleosteus, but anyway, it's been shrunk recently. Careful study of the anatomy that we have, like those, the bony plates in its head that form its jaws and its skull and everything. Those are the parts that we actually have preserved. The rest of the body, we don't have as much of. And so I don't remember exactly what it was that prompted its downsizing, but it is now thought that it was a lot shorter. Yeah. Anyway. Crazy head on that guy. Oh man. I forgot how short, says Petrodactylus, yeah. So it had a huge head relative to its body size? You could say so, Dr. Morbius, yeah. A short king, says Ariathelium, yes. Here, let's look up Dunkleosteus. I've always said Dunkleosteus, but it should be Dunkleosteus. It's named after a guy called Dunkel. And all of the folks from Ohio, Ken, who joined us this summer when we were working the Almond Formation of Wyoming, the folks from Cincinnati, they pronounced it Dunkleosteus. And, oh boy. Anyway, Dunkleosteus is kind of an emblem of the U.S. state of Ohio. The majority of Dunkleosteus fossils, I believe, have been discovered in Ohio. If there's one fossil that's really associated with that state, it's Dunkleosteus. And so, I've always said Dunkleosteus, but I'm going to probably take the Ohioans' pronunciation and use that because I'm sure it's more proper. In the same way that, I, living here in the San Francisco Bay Area, I rankle a little bit. I go, ugh, when somebody calls this city Frisco, Ugh. What? It's not what locals call it, I think respecting local customs is important when we can. So I don't know. I'll say Dunkleosteus, and you know what? I'll do it enough that it'll start to feel normal after a while. Anywho. Yeah. I know it's not Frisco or San Fran. San Fran is almost acceptable. I don't know. Here we just call it the city, Or, if you want to be cutesy about it, you can say SF. Just don't call it Frisco, Just don't do it. So anyway, Dunkleosteus. Where did it go? I gotta get rid of some of these tabs. Dunkleosteus.
Did you ever, though, have a moment where it was kind of heartbreaking? I'm
No.
destroying. Never.
No, glue is cheap.
Plane shifter in. Thank you for the 3 months of support. I really appreciate that. Thank you. Good stuff.
Glue is cheap.
Yeah, size and anatomy estimations. Okay. Good stuff. So, let's see. Estimations of the size. Right here. 2023. So yeah, a significant decrease in size according to these estimates. Oh, these are different fishes, different placoderm fishes of the same taxon, apparently. Anyway, yeah, if you want to read more about Dunkleosteus, this is a great place to start, honestly. Yeah. Engelman 2024, just last year, that you had the enshortening of Dunkleosteus. I'm not privy to a lot of the details. I didn't really have time to follow this story all that closely, but yeah, Dunkleosteus. Shorter than it may have previously been imagined. Chonk, this is Petrodactyl. Yeah. Kind of the, you know, the carbine version. It's shortened. Still packs good punch, though. Yeah. Shrink that man, Salamander. Yeah. Anywho. Yeah. Anywho. Yeah. And Ken says you can't call it the city because every major metro area is called the city by surrounding areas. Lol. No, I'm pretty sure that in New York State, you know, all the New Yorkers, you know, they refer to New York City as the Big Apple. They all say that in casual conversation all the time. They say the Big Apple. I'm sure they do that. I'm sure they don't call it the city. No, you haven't. You definitely have a point. Anyway, yeah. Oh, good stuff. And I missed that talk. I didn't get to see that one in Cincinnati. Yeah. Again, that was the same exact weekend as TwitchCon, and I had to make a difficult choice that year. Until they find bigger apples, says Gary and Kellis. Yeah. Yeah. And they will one day find a bigger apple, you know? Yeah. Here, like here. Here's I think this is like a TED Talk, right?
Pretty big, right? I think it is. I found it. This rock is in Scotland. It's big. Probably the biggest rock I had ever seen. I rolled it around, stared at it for a while, thought about how big it was, and I figured that would be the end of it. Until I found this rock a few years later in California.
So this talk is very inspiring. It's all about her, you know, finding the biggest rocks.
I was thinking about big numbers. Before all this, I was a math professor. I hadn't even been thinking about big rocks. I was thinking about big numbers. But here, don't matter.
Anyway.
I am going to show you where, in the future, we will find the biggest rocks on Earth. Space. If we go into space and we find a rock that is bigger than the biggest rock on Earth, and we bring that rock back to Earth, it will be the biggest rock on Earth. And this isn't science fiction. I am working with people right now who know how to do this. I can't tell you who they are.
In Silicon Valley, no doubt.
So far, all I can tell you is that there is no need for you to keep looking for big rocks, since I have already found the biggest rock on Earth. And even if you find that one, I will bring a bigger one from space, so I will still always be the person who has found the biggest rock on the Earth. Thank you.
Incredible. Good stuff. How do we get on this? Fatalis says, I didn't know the Onion did talks. Oh man, they're so good. Some of them are not necessarily appropriate for, you know, for our streams here, but some of them are pretty mind-opening, you know? Like this one.
The duck says, quack.
Wow.
The chicken.
What's the chicken say?
Says cluck. Quack, quack, says the duck. Cluck, cluck, says the chicken.
No way.
Ducks come from an egg.
He's right, you know.
Ducks like to swim in the water.
They do.
Quack, quack.
Do you catch that? He said quack, quack.
Chickens come from an egg. Chickens like dirt. Chickens do not like the water.
Wow.
So,
this is pretty profound stuff.
Why does the duck say quack?
Why do you think, chat? Why does the duck say quack? You know? Why? Why do you think? Let's see.
To talk to his duck friends. What does the cow say?
It's like, wow, yeah.
The cow says,
What does the cow say, chat? What do you think? What do you think?
moo.
Dirter. Dirter.
He doesn't say dirter. Yeah. Again, so for those of you who might have missed it, important information.
Says, moo.
What you're doing? Tradoon.
The farmer is friends with all of the animals on the farm. The animals are friends with each other. So, how do we get our duck to cluck? How do we get our chickens to quack? That is up to you. Thank you.
Good stuff. Again, I don't remember how we got on that.
I can see
Sculpin.
that 50,000 a year has been well spent.
Thank you, Sculpin, for supporting this extremely important science outreach where we cover such, arcane and vital topics as the duck says quack. In all earnestness, though, Sculpin, I appreciate you. Thank you. Thank you for the 20 months of support at Tier 3. Holy cow. Good stuff. Here, let's get into some actual science now, shall we? Let's talk about a new paper that just came out. And, well, here, before we do that, I keep forgetting. Let's do a Blue Sky post. Control, print screen. There we go. Let's see if I'm able to take a halfway decent photo here. Excuse me. And then we'll get into this new paper about early dinosaur evolution. 600 dpi should do it. I don't know, I look kind of smug in that photo. Let's do a different one. See if this is any better. That is better. I like that better. Run with that one. I should really try and remember to do this at the beginning of the stream, but that's okay. Better late than never. Grab that image. We're talking about convergent evolution. What else have we talked about so far? Common ancestry. Ducks. Ducks to go moo. Why ducks go quack. And other enigmas of natural history. Let's say other profundities. Paleontologizing. You're on paleontologizing. What belongs in a museum? Sorry, I had to hit the number pad for that. So come join us. That new paper on twitch.tv/paleontologizing. There we go. Let's add some alt text. Screenshot from Twitch stream of some doofus sitting in an office with some 3D printed dinosaur skulls. Stuff behind him. Okay. Save. And
hold on to your butt.
Post. Yeah. There we go. There's a link if for whatever reason you would care to boost this. There you go. But yeah. Yeah. Good stuff. And already we've got notifications. There. April, PyroKitty, and Claire Birth, thank you for reposting. I appreciate that. I really do. How am I not following me yet, Claire? There we go. Good stuff. Let's get into that new paper. The headline is, Dinosaurs likely originated in low-latitude region of supercontinent Gondwana. This might actually run slightly counter to a paper that we were covering just a week or two ago. But first, in order to provide some background information for some people here in the chat who might be a little bit new to some of these concepts, let's talk about what Pangaea is, what Laurasia is, what Gondwana. And Paleontologist VA, good to see you. Welcome back. Good to see you. This topic feels very similar, says Charlie's Dragon. Yeah. Let's see. We'll see. Here. Let's go back to 240 million years ago. This is what our own planet Earth looked like around 240 million years ago. So lots of different lines of evidence show that Earth had a massive supercontinent at the time. All of the continents were kind of smushed together. This is the thing that happens. Since the continents are constantly moving, these tectonic plates are drifting over the Earth's mantle. Sometimes they come together and collide, and then they break apart again, and maybe they recombine on the other side of the planet. They're just always kind of bouncing around over hundreds of millions of years. The continents move at around the same speed that your fingernails grow. So, not very quickly, but given enough time, they can literally move all the way around the world until they bump into one another and stuff. And so, around the time that the first dinosaurs evolved, this is basically what our planet looked like. South America and North America stuck together. Africa, right here, nuzzled up against South America. You have India and Madagascar and Antarctica and Australia all stuck together down here. In the north, there's Europe and Asia. And so, during the Age of Dinosaurs, the continents start to break up. They're moving and shifting. Here you have the beginnings of the Atlantic Ocean around 170 million years ago, 150 million years ago. South America and Africa still clinging tightly to one another. And then they start to split around 120 million years ago, 105 million years ago. They're coming apart 90 million years ago. Yeah, sea level's very, very high 90 million years ago. And etc., etc. You get the idea. But as this is starting to happen, let's go back to, say, 150 million years ago. You have this split to start to take place between the continents up north, North America, Europe, Asia. As sea levels rise and fall, it's often possible for critters to walk across land bridges between North America and Europe and Asia. And then in the southern continents, these are still largely stuck together. South America, Africa, India, which used to be stuck to the side of Africa, Australia and Antarctica, these southern continents together are what we call Gondwana. The northern continents, up here, North America, Europe, Asia, are what we call Laurasia. Up here, Laurasia, Gondwana. And so, this new bit of science just published says dinosaurs likely originated, first evolved in low-latitude region of supercontinent Gondwana. So, again, this would have been 240 million years ago, where all of the continents were stuck together. They're just trying to pinpoint where on Pangaea, this massive supercontinent, in which spot did the dinosaurs first show up? In which spot did they first evolve? Do dinosaurs first split off from their reptile ancestors and start doing their own thing? So yeah, we've actually seen this art before, but anyway. Dinosaurs dominated Mesozoic terrestrial ecosystems, so during the Age of Dinosaurs, the land ecosystems. Dinosaurs ruled the land, and started ruling the land They ruled the land for approximately 160 million years, which is a ton of time when you think about it. We as human beings have been ruling the planet for what? I don't know. Three, 4,000 years for being generous? Maybe 5 or 6. I don't know. It kind of depends. Well, let's be really generous. Let's say 20,000 years. And human beings have been ruling the planet for 20,000 years. And look how much we've managed to mess it up during that time. Dinosaurs, on their hand, 160 million years. $160 million years divided by 20,000. So dinosaurs ruled the Earth for 8,000 times longer than we have, even being super generous about human rule on Earth. They were much better stewards of our planet than we are. Holy cow. Anyway. But their biogeographic origin remains poorly understood. Where did the first dinosaurs evolve? We don't really know because, well, for one thing, we don't have fossils of the very first dinosaurs yet. So that certainly puts a fly in the ointment. But with that limited amount of information, what can we surmise? What can we try and figure out? You know? The earliest unequivocal dinosaur fossils appear in South America and Africa 230 million years ago. So that's critters like Eoraptor. This animal right here. This is, if you were to ask 10 different paleontologists what was the first dinosaur, 10 different dinosaur paleontologists, what was the first dinosaur? They'd, 6 of them would probably say Eoraptor, and then you'd get 4 other answers. The first dinosaurs looked something like this. About 230 million years ago in South America and Africa. Again, South America and Africa were linked together. So here's the kind of tricky thing about dinosaur origins is, if you think about it, it could have happened just about anywhere on Earth because, well, shoot. All the continents were together at the time, So anyway. But the earliest unequivocal dinosaur fossils, the ones we know for certain were dinosaurs, none of these things that are really fragmentary and they might be dinosaurs, they look like dinosaurs, we can't really tell. A lot of these things like, brain fart. What's the critter from southern Africa? It's not Nanosaurus, but it's, not Inquebasaurus. What is it called? Shoot, I forget. This is gonna bother me unless I find it. So let's see if we can find it. Nyasasaurus. There we go. Nyasasaurus may or may not actually be a dinosaur. The fossils are so poorly preserved that, like, this is the illustration of the bones that we have. We've got some weird scraggly pieces of vertebrae, upper arm, possibly a few other pieces. Middle Triassic Manda Formation of Tanzania may be the earliest known dinosaur. I don't think we even have photos of the specimens. I think they're that scrungy looking that it's like, why even bother? Here, let's do an image search for the specimen number and see if we can find it. Okay, that's better than I thought. Huh. But anyway, it's so fragmentary that we can't really even tell that it is from a dinosaur, potentially. It's hazy. Anyway, the point is, the oldest unequivocal dinosaur fossils that we have are from South America and Africa, about 230 million years ago. Yeah. Anyway, Neosaurus is the one that I was thinking of. There's a link if you want to read more about this, if you are curious. Yeah. Nyankatsaurus is Mayor's face. Not quite. But, oh, this is after you were... Yeah, okay. We're all good. Yeah. So anyway, most authors have proposed that southwestern Gondwana is the likely center of their origin. But again, like we talked about the last time, we were talking about dinosaur origins. It might be an example of searching for the keys under the lamppost. Is this where you lost your wallet? No, I lost it in the park, but this is where the light is. You know? We have rocks that bear a lot of really good fossils from places like, you know, the Estiguolasto Formation of Argentina, South America. And so we know we can find good fossils there. So that's where people go to look for some of the earliest dinosaurs, and that's where they find the earliest dinosaurs so far. But that's not where the earliest dinosaurs probably lived. It's really hard to find rocks of the right age to be from the origin of dinosaurs. And so sometimes, yeah, sometimes it is a streetlight effect kind of a thing. And there you go, Estiguolasto, exactly, Ken, yes. Yeah. So yeah, and Ken says that's pretty good for the Middle Triassic. Yeah, like these fossils here, they might not look particularly impressive, but we don't have a lot of material from the Middle Triassic. We don't have a lot of rocks of that age. We don't have a lot of fossils from that time. And so, this is kind of the best we've got, and we can't really tell if it's a dinosaur or not yet, you know? So yeah. Yeah. The high diversity of these earliest assemblages suggests a more ancient evolutionary history. This is why I say, you know, long-term viewers of this channel, people who've been here for a long time, you know, when I talk about the earliest dinosaurs, I say about 240 million years ago. When we look at our chronostratigraphic chart, I usually say about 240, maybe like the Ladinian stage of the Middle Triassic for the evolution, the earliest evolution of dinosaurs, when dinosaurs first become a clade, when they first become their own group. They first appear. But that's not when the earliest dinosaurs are from. The earliest dinosaurs we have are from the Carnian stage. But they're already very clearly dinosaurs. We're looking for, like, the beta version. Or even, like, you know, pre-alpha stage dinosaurs. They would have looked more primitive, less dinosaur-y. They already look too dinosaur-y by this stage. We already know for sure that they're dinosaurs. They can't be the first dinosaurs. There's got to be something before them. Maybe here, in the Ladinian stage, the Middle Triassic. They agree here. Yeah. The high diversity of these earliest assemblages, so the fact that not only do the dinosaurs look dinosaur-y, but there's a bunch of different kinds already. And we know all dinosaurs came from a single common ancestor, from one species. All clades are like that. They all have to come from one origin point. And so, if we've already got a bunch of different dinosaurs, that means obviously we're looking too late. It's not the first dinosaur, because there's multiple different species. So yeah, the high diversity of these earliest assemblages suggests a more ancient evolutionary history. New research led by University College London shows that dinosaurs and, potentially, their Archosaurian relatives as a wider group likely radiated in the low-latitude region of Gondwana. And there's Neosaurus, like we were talking about. Could be the earliest known dinosaur, or else a close relative of early dinosaurs. It's a Mark Whitten illustration. So currently, the oldest known dinosaur fossils date back about 230 million years ago, and were unearthed further south in places including Brazil, Argentina, and Zimbabwe, said University College London PhD student Joel Heath and colleagues. But the differences between these fossils suggest dinosaurs had already been evolving for some time, pointing to an origin millions of years earlier. The authors found that the earliest dinosaurs likely emerged in a hot equatorial region, in what was the supercontinent Gondwana, an area of land that encompasses the Amazon, Congo Basin, and Sahara Desert today. I wonder why they think that. But anyway, this is the thing that you often hear about the Triassic is during this time, when you've got all the continents kind of smushed together like that, you would get these huge inland areas that would have been extremely hot and dry. Think about like a continental climate today, an area far inland, a place like Mongolia or like Wyoming, way in the center of the continent. You get these extreme temperature swings. It tends to be pretty dry. You're very far from the ocean and the evaporation and precipitation that comes with that. You're far from any large body of water. And so these areas fluctuate between extreme heat and extreme cold, especially if they're far from the poles. Or far from the equator, excuse me, if they're near the poles. During the Triassic, things would have been warmer than they are today. And there would have been just massive deserts across the center of the continent. Does that make sense? Yeah. So suggesting that dinosaurs emerged in a hot equatorial region, what was then the supercontinent Gondwana, that's, it's not a stretch. That's pretty close to the general kind of hunch that everybody has, I think. Or that most paleontologists have about this particular time. Dinosaurs are well studied, but we still don't really know where they came from. The fossil record has such large gaps that it can't be taken at face value, he said. Our modeling has suggested the earliest dinosaurs might have originated in western low-latitude Gondwana. I do wonder what their methodology is here. Again, there's a bit of a philosophical difference that I think I might have with these authors. And maybe we'll talk about this with Denver Fowler next week when we're in North Dakota. But this idea that the fossil record has such large gaps that it can't be taken at face value? To be sure, there are gaps in the fossil record. There are gaps in the rock record. There are things that don't fossilize as well as other things. So, like, the fossil record can be biased in certain directions. You will find fossil shells much more commonly than you will find the fossils of, say, slugs or something. Soft-bodied organisms that don't preserve well. Everybody knows that. But sometimes I feel like the fossil record is incomplete, it has such large gaps. Within geological formations, I think a lot of that is collecting bias. I think in a lot of cases, the fossil record is more complete than we give it credit for, and it's just poorly sampled oftentimes. But maybe I'm nitpicking here. If they had just said, oh, it's poorly sampled in certain areas, I would have said, yes, for sure. But, yeah. Anyway. And there you go, Galrox. That's exactly what I'm saying, word for word, yes. Anywho. So this is a hotter and drier environment than previously thought, made up of desert and savanna-like areas. So far, no dinosaur fossils have been found in the regions of Africa and South America that once formed this part of Gondwana. And I wonder how well explored those areas have been, but yeah. However, this might be because researchers haven't stumbled across the right rocks yet, due to a mix of inaccessibility and relative lack of research efforts in these areas. Yes. The study drew on fossils and evolutionary trees of dinosaurs and their close reptile relatives, as well as the geography of the period. It accounted for gaps in the fossil record by treating areas of the globe where no fossils had been found as missing information, rather than areas where no fossils exist. This is cool. Okay. So this is trying to account for the streetlight problem. Rather than saying, oh, well, no one's found fossils in these areas because those fossils never existed, it's saying, okay, that's just nobody's looked, rather than it being no fossils. Does that make sense? Treating the areas of the globe where no fossils have been found as missing information, rather than areas where no fossils exist. Initially, early dinosaurs were vastly outnumbered by their reptile cousins. These included the ancestors of crocodiles, the Pseudotsuchians, and pterosaurs. I don't know how common pterosaurs were in the Triassic, but yeah. You had all kinds of other critters. Every time we talk about these Triassic ecosystems, these ecosystems from the Triassic period, at the beginning of the age of dinosaurs. Again, dinosaurs first evolved probably about here. We get them throughout the upper Triassic. Dinosaurs are truly dominant on our planet all throughout the Jurassic period and all throughout the Cretaceous. And only when that asteroid hits at the end do they cease to be the big guys on the block. Only the birds survive, and only a few species of birds at that. But yeah. Here. Here we go. I love this. Nice roster of the Esquigolasto Formation. So this is in Argentina. About 230 million years ago, the earliest unequivocal dinosaurs that we have are from the Esquigolasto Formation. Things like Eoraptor, and maybe Herrerasaurus, but we're not really sure about Herrerasaurus. Most of these animals are not dinosaurs. I want to make that very, very clear. So, the only ones that are dinosaurs are Eoraptor, Anphagia, little guys, probably Herrerasaurus, and probably Pisanosaurus, although that might be a Silosaur, but Silosaurs might be dinosaurs. So anyway, 4 of these guys are dinosaurs. Everybody else, not a dinosaur, including the big top predators in that ecosystem, things like Saurosuchus. That's a crocodile relative, not a dinosaur. These are dicynodonts up here, critters like Esquigolasto. Esquigolasto is a dicynodont. It's related to mammals. It's not even a reptile. So dinosaurs were not the big dominant animals when they first appear. They're, they show up and they're just another member of the community, Only later do they take over. Do dinosaurs diversify into this paradigm where every big animal on land is a dinosaur, practically, except for a few crocs here and there, So yeah. So Mythundere says, what are the others? Oh, Mythundere, good to see ya. Yeah. Dicynodonts like this guy and this guy are mammal relatives. This is a Rhynchosaur, which is like a weirdo reptile. We've got Phytosaurs and Aedosaurs. These guys are sort of semi-crocodile-y reptiles too. Yeah, who is this? Silosuchus. I'm not even sure who this is, but another reptile. And then you get the weird proto-mammal-y guys, the Cynodonts. Things like Chinquodon and Exalerodon right here. These are like mammal relatives. Yeah. So yeah, dinosaurs were part of the community. Not super common. Definitely not dominant in the ecosystem. They're there when they first start showing up, but it's only later that they become dominant, after you get the extinction of these other groups. Basically, all of these other guys go extinct. These guys may have evolved into mammals. I don't know what the current thinking is on the kind of mammal ancestry guys. They're probably not on the direct line to modern mammals, but they're close, I'm sure. The cynodonts. But yeah. Anyway, basically everybody goes extinct, except for maybe these guys. They may have turned into mammals, or their close relatives may have turned into mammals. And then the dinosaurs take over for the next 150 million years. They run riot upon the earth. They are everywhere. Yeah. Anywho. Oh, taking a brief detour here, Dr. Tara's got a question. On Twitter, Jim Kirkland, Papa Jim, mentioned about how Utahraptor could simply walk to Europe as it was connected to North America at the time. Yeah, that would have been about 130 million years ago. Here, so we're going to jump from the Triassic period to... This doesn't have 130, so we'll do 120. 120 million years ago, at various times, North America was linked to Europe via various land bridges. Sea level rises and falls, and these land bridges form, and then they get submerged again when the sea level rises over millions of years. You get the idea. But at one point, you would have been able to walk from Utah here to Europe. And we do get a lot of dinosaurs in North America at the beginning of the Cretaceous period. At this time, they clearly came over from Europe. They were European dinosaurs that looked just like that before, and then afterward they show up in Utah. So I think that's where they're coming from. So Dr. Tara says, I'm curious, is this when the Tyrannosauroidea migrated... the Tyrannosauroidea material from the Cloverleaf came from? Eotyrannus traveled to North America. If so, what happened to them? As Moros are more Asian members of the family that got to North America. So yeah, that's a different thing. Yeah. So we get dinosaurs in Utah that clearly come over from Europe around 140 million years ago. That may be where Utahraptor came from. It could be that we had dromaeosaurs in Europe first, and then you get this extinction event at the end of the Jurassic. A lot of your classic dinosaurs in North America get wiped out. We're still trying to figure that out. But yeah, they seem to be replaced from critters coming up from Europe. And then later on in time, around like Mustn't Touch It time, so around, it would be like 100 million years ago, give or take. So... let's try this. 90 million years ago. That's close enough. At this time, the connection between North America and Europe is severed, but there's a connection between Western North America and Asia. So you could walk over from Mongolia, from China, across this land bridge here into the western part of North America. And that might be where critters like Moros come from, if they're indeed descended from Asian ancestors. Does that make sense, Dr. Tara? Yeah. So yeah, again, it's only in the last decade, really, that we've been able to ask these questions in a detailed way and have answers that seem convincing. We're kind of at this really neat time in dinosaur paleontology where we're starting to be able to figure out, because we've got more precise dates, we've got better paleo maps, we've got a better idea of what the continents are doing at different times. That's starting to match up with what we see in these different dinosaur assemblages that we dig up. Oh, well, these dinosaurs here in Utah from this time, they look awful similar to the ones from just before in Europe. Oh, that makes sense, because There's probably a land connection between Europe and North America at that time. And then that gets severed, and then those dinosaurs start to evolve in different directions. And then you got all these dinosaurs that look like they're descended from Asian ancestors show up in North America. Afterward, well, turns out, shoot, we've got other lines of evidence that show that there was a land connection between North America and Asia at that time. So the puzzle pieces are starting to fit together in a way that I think is really, really cool. Like, this is a really exciting time to be a dinosaur paleontologist. If you're interested in paleobiogeography, if you're interested in the movements of these different dinosaur lineages across the Earth, and like, they evolve over here, and then these ones go extinct, and then they get replaced by these ones that come across the land bridge, that kind of thing, you know? It's cool stuff. It's very cool stuff. So yeah. Anywho. And Mythundere says, have there been any points where the land masses were aligned such that you could walk around the Earth in a circle, like around the equator? Not that I know of, no. Here, again, if we go back to Pangaea, 240 million years ago, give or take. Basically, you've got land on one side of the Earth, and you've got water on the other. That's why we call it Pangaea and Panthalassa. Panthalassa meaning all ocean, like thalassophobia, fear of the ocean. Pangaea, Gea like geology or like Gaia, same root word meaning earth. Land, you know? Yeah. Not the equator per se, but like 40,000 kilometers straight line on the surface. I don't think so. I think that's the thing about Earth's continents is they're not big enough to wrap all the way around. So when they come together, it's because they've bunched up on one side. And then they break up again, and eventually they go back around to the other side, and they bunch up on the other side. So if you have a massive supercontinent, it generally seems to mean that it's because all of the continents got log jammed on one side of the Earth. You know? Yeah. Here, and we can talk about that. Yeah. Here, let's talk about supercontinents. Here's a lovely PBS Eons video. You know, we're very fond of PBS Eons here. Good stuff.
By now, you've surely picked up on the idea that the study of natural history is basically the study of how the world has changed. The study of how we all got here. And of course, the world continues to change all the time. I mean, literally. I'm not just talking about how life adapts or how the climate is changing. I mean, the planet itself as an object is in a constant state of flux because the ground beneath your feet is always moving. So the place where you are right now was not always there. For example, if you're watching me in California right now, then
I am watching in California right now. How did he know? From the beautiful, sunny San Francisco Bay Area, in fact. Wow. There.
About 500 million years ago, the place that you currently think of as here was actually on the equator. And it was underwater. Likewise, if you're in the UK, then your here was almost...
Do we have anybody in the UK right now?
Equator. And it was underwater. Likewise, if you're in the UK, then your here was almost at the South Pole, and your next door neighbor was Africa. We know all of this thanks to paleogeography, the study of how the physical face of Earth has transformed over time. And it's this movement of the continents that has driven many of the major revolutions in life's history. Its advances and its setbacks, its explosions of life and its extinction events. So if natural history is the study of how we got here, then you also have to understand how here got here.
Yep. Yeah, and so there's... We'll continue with this, but I want to show you a really, really cool map. This is some pretty awesome stuff. Here is a map of Pangaea. It's simplified, but this is like, you know, at the end of Well, around the beginning of the age of dinosaurs. So, like, end of the Paleozoic, beginning of the Mesozoic, when all the continents were stuck together. Things would have been morphed and squished in, like, various interesting ways, so this is a simplified version of it. But it's really neat in being able to say, oh yeah, well, shoot, back in the day, we would have been able to walk from New York City to West Sahara and Morocco. Just, there you go. Right there. You know, Greece would have been pushed up against Libya. Antarctica in India, two places that you don't think of as being very similar today, and certainly they are not. They used to be neighbors, you know? So this is cool. It's, again, not supposed to be a scientific map, it's just trying to show you this idea that the places that we know and love today didn't used to be where they are today. So I used to have this printed up on my wall back when I lived in Montana, and it was honestly one of my prized possessions. Pretty cool stuff. Pretty cool stuff. Anyhow.
If you want to know how your here got to be where it is, you first have to know where land comes from and how it behaves. And for a long time, we just didn't know. The idea that the
comes from turtles, right? I think a wise man told me that once. All land is turtles, right? And then they're stacked on top of each other. There's some people who still, like, literally believe that, basically, but yeah. Anywho.
First have to know where land comes from and how it behaves. And for a long time, we just didn't know. The idea that the continents could actually move was first proposed in 1912 by German scientist Alfred Wegener. He spent years traveling the world.
I don't know if he first proposed if he was the first person to propose this, but he was definitely the first person who ever had, like, strong ideas that were taken anything close to seriously.
Collecting geological and fossil evidence to argue that all of the continents were once connected. Wegener was the first to propose the idea of continental drift, and the notion was so outlandish at the time that it basically cost him his career. And part of why no one accepted Wegener's theory was that no one in his day had ever seen the bottom of the ocean. Until the mid-20th century, most scientists assumed that the seafloor was basically featureless, like a giant wading pool. But in the 1950s and 60s, pioneering researchers like Marie Tharp and Bruce Heezen began studying the bottom of the ocean. And they found that there was an enormous mountain range running right through the middle of the Atlantic. Eventually, more of these undersea mountain ranges, called mid-ocean ridges, were found in all the world's oceans, and they were all volcanically active. These ridges, it turned out, are where the seafloor is made. Geologists realized that these mid-ocean volcanoes are actively creating the rocky material of the seafloor and spreading it outward in a process called seafloor spreading. But what the sea gives, it also takes away. Far from these ridges, at the edges of continents, researchers also found huge trenches. And here, the dense rocks of the seafloor dive below the lighter rocks of the continents in a process called subduction. So the denser, heavier crust that makes up the seafloor, known as the oceanic crust, moves under the lighter land masses, known as the continental crust, just a few centimeters at a time. And as oceanic crust sinks back into Earth's interior, it begins to melt and mix with the mantle. So seafloor spreading and
And as it does that, as it sinks below and melts in the mantle, you get heat that's generated from that ends up sometimes causing volcanism or pushing up mountain ranges along the coast. So again, back here in the beautiful sunny San Francisco Bay Area, these hills, mountains, whatever you want to call them right here, this is called the Coast Range. There's a range of mountains like this that runs along the coast because this is at a continental margin. The Pacific Plate over here is pushing down, it's getting subducted under the continental plate, under the main continent of North America. And as it does that, as it sinks below, it melts as it goes into the Earth's mantle, and that creates these plumes of heat that slowly push up these coastal mountains. Does that make sense? That's also why we have the Sierra Nevada too, is because at that point you go further and further east. As that Pacific Plate is plunging below, I think that's the idea, is that, you know, it really starts to get pushed down and it melts, and then that pushes up the Sierras. So yeah. Anyway. Good stuff.
It also takes away. Far from these ridges, at the edges of continents, researchers also found huge trenches.
And Gaurok says, look at this image. Does it mean that the core of the planet would have currents? Not the core. The core is like the very, very middle, you know? You may be talking about the mantle, which is like the kind of the outer part. And somebody like Rocket Sage would be able to explain this better than I could. This is closer to her area of expertise than it is to mine, certainly. Here we go. So, you've got the interior of the Earth. Not to scale. There you go. Yeah, this is not actual size for the Earth. But yeah, the crust, which is on the Earth, it's basically like if you were to hold an apple in your hand, the skin of the apple would be thicker than the crust of the Earth if the Earth were the same size as that apple. Does that make sense? So the skin of an apple is proportionally thicker than the crust of the Earth is. And you got the mantle, the outer core, and the inner core. There are various things going on in there. There's... I don't know. I'm not an expert on this subject. This is outside my realm of expertise, but I don't know if we'd call them currents or what, but like things do churn around on the inside to a certain extent. But the closer you get to the core, the more and more solid things get. Where the Earth's core is molten, but it's also so compressed that it's essentially solid. It's like molten iron that's behaves like solid iron, as I understand it. Something like that. I'm grievously oversimplifying, but you know, suffice it to say that there are scientists who study this who could talk your ears off about it. I'm not one of those scientists. I work on dinosaurs, for crying out loud. This is outside my realm of expertise. But yeah. Yeah. And the core is solid iron. Something like that, Roland. Yeah. Yeah. We should ask her if it's possible to invent a giant drill vehicle that could drive around in the core like in the film The Core. Yeah, it's not possible in airspace. At least, I don't know, if... Yeah. I feel like it would just instantly get crushed, you know? It would be like... I don't know. I can't think of a good analogy. I was going to say, like, trying to take a toothpick and then force it into a drill press that's being compressed, like, under extremely high PSI, and you're just... It's not going to work, but, yeah. Anywho. Yeah. The point is, we've, over the past century, started to understand a lot about the way that our Earth actually works. And this is borne out in, well, in our daily lives in a lot of different ways. Things like oil exploration, you know, have both helped to, you know, map out the ocean floor in the first place. But also, like, a lot of exploration for oil takes advantage of this information. So, like, when you're driving your car, you're benefiting from this scientific knowledge, in a sense. Does that make sense?
Rocky material of the seafloor and spreading it outward in a process called seafloor spreading. But what the sea gives, it also takes away. Far from these ridges, at the edges of continents, researchers also found huge trenches. And here, the dense rocks of the seafloor dive below the lighter rocks of the continents in a process called subduction. So the denser, heavier crust that makes up the seafloor, known as the oceanic crust, moves under the lighter land masses, known as the continental crust, just a few centimeters at a time. And as oceanic crust sinks back into Earth's interior, it begins to melt and mix with the mantle. So seafloor spreading and subduction are the two key mechanisms behind plate tectonics, the theory of how giant chunks of Earth's crust, called plates, move around the surface. And together they explain what Alfred Wegener never could. They show us how the continents of our planet come together and break apart. But Wegener was right. Throughout the planet's history, land masses have been joining together to form supercontinents, only to break up again millions of years later. Supercontinents begin to separate when the mantle that's turning around beneath them starts to change, like in direction or temperature or intensity.
So there you go. Yeah, so stuff in the mantle does move around, and I'm not super clear on the specifics on that, so I'm hesitant to talk about it, but there is churning that goes on there, you know?
Separate when the mantle that's churning around beneath them starts to change, like in direction or temperature or intensity. These kinds of changes, we think, can cause plates that were once pushed together to gradually spread apart. When plates separate, they first create a rift valley, like the Great Rift Valley in Africa. Then as they keep spreading apart, they can form narrow seas, which is how the Red Sea came to be. Eventually,
Yeah, so we're going to see this. Well, no, we're not going to see this. It'll be long after I'm dead and all of you are dead. Sorry. It's just... I'm sorry if that's a shocking revelation, but the Great Basin and Range in the United States, western Utah and Nevada being stretched apart like that. And you can see this in the mountain ranges there. Spoiler alert, sorry, ended, yeah. Yeah. Yeah, so there we go. In the Basin and Range province, you just have, yeah. Nevada is basically being torn asunder like that. Slowly, slowly, slowly. But in a few million years, that's gonna be ocean, you know? Yeah, Terminator Pig says, I'm about 9 million years old. I'm not going to die. Good for you, Terminator Pig. I appreciate you spending time. I suppose your time is not as precious as other people's is, but I still appreciate you spending it here on Paleontologizing, Terminator Pig. I appreciate it. Yeah. And there you go, Charlie's Dragon. Yeah. It's funny. There's at the end of John McPhee's book, Basin and Range, you know, he talks about this Basin and Range extension like that, and how eventually, you know, the middle of Nevada will be beachfront property. And it's like talking about this with random townspeople in the middle of Nevada. It's really funny hearing their responses. Do I have that book here? Can I put my Basin and Range? Here. Let's find that. There we go. So, a big part of the book is John McPhee traveling around with a geologist named DeFaze through Nevada and Utah and the Great Basin and Range province. So he says, I hand DeFaze the Exxon map and ask him to sketch in for me the opening of the new seaway, the spreading center as he sees it coming. Of course, all the valleys in the Great Basin are to a greater or lesser extent competing, he says, but I'd put it where I said, right here. With a pencil, he begins to rough in a double line like a swath about 15 miles wide. He stretches it from the axis of Death Valley and up into Nevada, then north by northwest through the basalt and coalade before bending down north into the Walker Lake, Fallon, and Lovelock, Nevada. The spreading center would connect with the transform fault coming in from Cape Mendocino. Yeah, it's Cape Mendocino in California. And he sketches such a line from California coast to a point a little north of Lovelock, Nevada. He is sketching the creation of a crustal plate, and he seems confident that the edge from the Mendocino Transform Fault, the Mendocino Trend, and its place is now ready to go. He's less certain about the northern edge of the new plate, because he has two choices. The Garlock Fault runs east-west just above Los Angeles, and that could become a side of the new plate, or the spreading center could continue south through the Mojave Desert, yada yada. Kind of going through the details here. My mind has drifted outside the building. I am wondering what these people in this dry basin, a mile above sea level in Nevada, would think if they knew what DeFaze was doing, and if they were confronted with the news that an ocean may open up in their town. Again, this would be tens of millions of years into the future. I will soon find out. What? Are you stoned? Different responses from people. The way I see it, I won't be here, so the hell with it. Someone else says, it's a little doubtful. It could be, but it's a little doubtful. If it happens real quick, I guess a couple of people will die, but if it's like most other things, they'll find out about it hundreds of years before and move people out of here. The whole world will probably go to hell before that happens anyway. Person's more right than they know. You mean salt water, crest, troughs, big splash, and all that? Don't sweat it. You're safe here. As long as Pluto's out there. Wait, I don't know what that person meant. We got a boat, another person said. Someone else said, that's the best news I heard in a couple of years. When I go bye-bye to the place below, why, that water will be there to cool me. I hope it's Saturday night. I won't have to take an extra bath. Anyway, it kind of goes on like that. And that's the end of the book. I think it kind of highlights that when you start to understand geology, you start to understand these big earth processes, it's kind of changing your viewpoint a little bit. Not to be all like highfalutin about it, but educating yourself. You've got that perspective and you can think about things tens of millions of years in the future and have those thoughts be based on real information. And that's not the sort of thing that most people do in their daily lives. It's not something they ever really consider, But as earth scientists, that's what we do, Geologists, seismologists, hydrologists, paleontologists. These are the sorts of things that we think about, Gotta love John McPhee. Agreed. Neverwinter. Yeah. Yeah. And Gazaway says, if a landmass has an ocean over it, the mantle becomes thin, doesn't it? Like if that ocean dissipates, does that make the geological change occur faster on that land? I don't think the mantle doesn't become thin. The mantle is always constant thickness. Unless you're talking about, if you do get like mountains building up, you can get, it's like you've got more, the crust is stretching higher and higher up into the atmosphere when you've got a mountain. And it's like, that does tend to sag after a while, and it can push down into the mantle a little bit. So it can cause a continent to sink a little bit, just because it's like, you get that uplift like that, and you've got all of this mass concentrated here, so it can start to weigh things down a bit. And then if you get a lot of erosion, you can get what we call isostatic rebound, where things start to push up a little bit because there's not as much weight holding it down. But these are things that I don't understand on a deep level. It's just, I have kind of the most basic understanding of how that works. So again, I'm not a volcanologist. I'm not a continental geographer. I'm not that kind of earth scientist, So yeah. Hey, Digital Dak, how are you doing? It's good to see you. Thanks for dropping by. Albeit briefly. I appreciate you. Yeah. Anyway, back to our video here about
push together to gradually spread apart. When plates separate, they first create a rift valley, like the Great Rift Valley in Africa. Then as they keep spreading apart, they can form narrow seas, which is how the Red Sea came to be. Eventually, these gaps can open up to become a whole new ocean. That's actually how the Atlantic Ocean formed. This whole process of continents...
So again, we're talking about that ocean forming in Nevada, like the ocean coming into Nevada when that area gets rifted apart. That is like what happened with the Atlantic Ocean.
Gradually spread apart. When plates separate, they first create a rift valley, like the Great Rift Valley in Africa. Then as they keep spreading apart...
Or like the Basin Range province in Utah, Nevada, and Eastern California.
They can form narrow seas, which is how the Red Sea came to be.
So yeah, the Red Sea there is a result of this, where it was rifted. This used to be dry land, and then it rifted apart. And as it did, the low parts were inundated by the sea like that. Yeah.
Eventually, these gaps can open up to become a whole new ocean. That's actually how the Atlantic Ocean formed. This whole process...
Neverwinter says the ocean is there because the crust is thin. Oceanic crust is denser and lies lower than continental crust. Yes. The crust isn't thin because the ocean is there. Exactly, Neverwinter. Yeah, yeah. You know, the ocean's going to go wherever it's lowest, you know? So in parts of the Earth where, you know, the crust is thin and it's not high up, that's where the water accumulates, you know? That's where gravity pulls it to.
Of continents coming together and splitting apart is known as the supercontinent cycle, and it is what has changed the face of the Earth over the eons. Now, you've probably heard of Pangaea, the landmass that contained almost all of Earth's dry land about a quarter billion years ago. For a long time, experts thought that was the world's first supercontinent. But today we know it wasn't the first, and it won't be the last. One of the earliest supercontinents that scientists have evidence for is called Knorland. It existed 2.7 to 2.5 billion years ago, toward the very end of the Archean eon. It was made of continental crust that would eventually become parts of North America and Africa. And even though we call it a supercontinent, Knorland actually wasn't much bigger than Australia is today. Life on Earth at the time of Knorland was probably mostly single-celled, like the photosynthetic cyanobacteria that were starting to add oxygen to the atmosphere. Then, 700 million years after Knorland spread apart, another supercontinent began to form, called Nuna, or Columbia, depending on who you ask. The northern reaches of Nuna included land that would eventually become North America and Antarctica. And in the south were the cores of South America and Africa. Nuna existed from...
So this is long, long before the first dinosaurs, you know? So this is when creatures were mostly, I think still 1.8 to 1.4 billion years ago. Critters are like mostly single-celled. You might have had like stromatolites and things like that at the time. But yeah, this is before the first animals.
From 1.8 to 1.4 billion years ago, in the middle of the Proterozoic eon. And it's here where we find fossils of the earliest plant-like organisms, red algae, which lived in a shallow sea in what's now India. Nuna broke apart, but the fragments came back together about 100 million years later. This new continent, called Rodinia, was the first supercontinent that geologists had found existed before Pangaea. And geologists were able to reconstruct Rodinia after they noticed that Labrador on Canada's east coast fit quite nicely into the west coast of South America. Rodinia broke apart.
Wait, can we see that again? Look at the little map.
Labrador on Canada's east coast fit quite nicely into the west coast of South America. Rodinia broke apart about 900 million years ago, and shortly after that, the world was plunged into another long ice age. About 650 million years ago, the next supercontinent, called Pangaea, came together. And here the first animals were found in the fossil record, living in coastal waters from the poles to the equator. First came the mysterious Ediacaran fauna, and then the animals that mark the Cambrian explosion. Animals probably did...
He just referenced
Curious Ediacaran fauna, and then the animals that mark the Cambrian explosion.
Yeah. What was that? History of the Earth, I guess? What was it? Anyway. Yeah.
Animals probably didn't live on Pangaea, though, because no fossils have been found in terrestrial rocks from that time. But the land wasn't lifeless. It had likely been colonized by pioneering bacteria, algae, and then the fungi. After Pangaea broke up about 550 million years ago, the continents began looking more like the world we recognize. 407.
And Cats of Skill says, what kind of records do they use to date these land masses with the animals as well? A lot of different ways. So radiometric dating is probably the one that you're thinking of, where you can look at radioactive isotopes. And it's essentially, to grossly oversimplify it, it's like looking at an hourglass after somebody's turned it over. Like, you can look at an hourglass and tell how much sand has gone through it. You can do the same thing with radioactive isotopes. You can tell how long that radioactive isotope has been decaying. And so that tells you how long ago that rock was formed. So stuff like that allows us to actually date those rocks, to put an actual number on how old they are. And then using that as a framework, we can kind of put other things in context. Oh, these rocks are from below. That means that they're older. These rocks are above. That means that they're younger. And then we can find other radioactive isotopes in other rocks, and we can start to like build a timeline like that. Grossly oversimplifying here, but I hope that makes sense. You know? And when did jellyfish start to fill the oceans? I think cnidarians like that, jellies, I want to say they're about 700 million years ago, give or take. I want to say like late Precambrian, but I'm not sure. We'll see. He might talk about... Actually, no. We've skipped that already. We're at the Ordovician period. There's already all kinds of shelled and fishy critters swimming around doing their thing at this time.
70 million years ago, in the Ordovician period, the first plants began to live on land. The earliest plant fossils have been found in South America, which was part of the continent of Gondwana. Then, 420 million years ago, in the late Silurian, the first millipedes crawled through the undergrowth on a separate continent just north of Gondwana. And it's known by the catchy portmanteau Euramerica, because it contained parts of both North America and Europe. Euramerica is also where the earliest fossils of insects have been found, about 20 million years later. Then, toward the end of the Devonian period, 365 million years ago, the first amphibians left the swamps to explore the ancient forests that would later form the coal deposits of Europe and North America. And then the earliest amniotes, vertebrates that lay shelled eggs on land, showed up 310 million years ago. Right.
So Archaeothyrus right here, I think, is the earliest synapsid. So the earliest mammal ancestor. Stem mammal. Like, this is on the mammal line, the mammal side of the amniote tree. So yeah. Our ancestor at one point looked like that.
Right before the formation of the most famous and most recent supercontinent, Pangaea. Pangaea began to form 300 million years ago at the end of the Carboniferous, when North America and Eurasia, together known as Laurasia, collided with Gondwana. And because there were no oceans in their way, animals were free to roam all over Pangaea, which is why similar species are found in areas all over the world in this time. But life...
Yep, and yeah, this is actually some of the earliest evidence for continental drift, that the continents moved. It's like, well, shoot, why do we have the same animals in India and Antarctica and South Africa and South America? What? Some of these animals are short and squat, and like they could not swim across oceans. Critters like the Dicynodont, Lystrosaurus. Here we go. Which again is not a dinosaur. It's like a, you know, proto-mammal. Guys like this. That's not an animal that's going to be swimming across an ocean. And yet their fossils are found in Antarctica and Southern Africa and South America and India too. What in the world? It's because they used to be able to just walk across, because those continents used to be stuck together. But yeah, does that make sense? Yeah. How big were they? Lystrosaurus not very big. Yeah, there's a bunch of different species, but I think that's one of the biggest ones. Yeah, largest species is, you know, like the size of a Great Dane, maybe. Yeah. No chance it could have floated, says Murph. Not across an entire ocean, no. No. You know, it would be like, you know, a horse falls off a boat in the middle of the ocean and you're like, oh, he'll be fine. He can swim a few thousand miles, he'll be okay. No. Yeah. Crazy Kyle says, I never stopped to consider fossils would be found in Antarctica. Neat, absolutely, yeah. Yeah. Antarctica is kind of an exciting new frontier for all different kinds of fossils. Not all different kinds, but many different kinds of fossils. Here.
The early Jurassic. Lush forests teeming with life of all shapes and sizes. This is not the Amazon. It's Antarctica.
Yeah.
190 million years ago.
Antarctica today is a very different place than it was in the past.
A team of scientists have traveled to the 160-kilometer-long Shackleton Glacier to uncover this lost prehistoric world.
If we want to really understand what's happening on a global level in Earth history, we have to go all over the place. We have to go to places like Antarctica.
Ancient fossils buried in the rock reveal creatures that went through hell on Earth in order to survive. Including the worst mass extinction in our planet's history.
Yeah,
it's a survivor
lineage, one of the few lineages of terrestrial animals that survived the Permian.
Yeah, Lystrosaurus. There's that critter I was showing you.
Lystrosaurus
that
was able to make it through the
Tony
worst
Martin.
that the Earth could throw at it.
From the ashes of this great dying, an Earth 2.0 emerges, with a new dominant force slowly coming to the fore. Dinosaurs. But as the continents split, how did they survive the polar conditions? And how did Antarctica transform into the frozen continent we see today?
Again, if you want to see more about this, there's a link. Nice documentary there. Yeah. By the way, I need to reach back out to
Places like it's happening.
Here.
Where did he go? Need to reach back out to
The Permian mass extinction event.
Lystrosaurus was able to make it through.
Yeah, I'm gonna see if we can bring Tony Martin on for an interview at some point, because he's I don't know, cool guy. It's always cool running into him at conferences, and he's expressed interest in paleontologizing appearance in the past, so I gotta actually make that happen sometime soon. But yeah. Anywho, oh, and I missed your question up top. Are you still here, Gazway? Gazway says, I was generally wondering about the geological changes caused by the loss of mid-continental ocean in North America. Oh, you mean the Western Interior Seaway? Yeah. Just curious if the presence of an ocean left the current crust different from the crust on the eastern and western sides of North America. Not really. Yeah. I mean, nowadays we're talking about talking about Kansas and Nebraska and Texas and parts of Wyoming and Montana and the Dakotas. The way that these are different is that we've got ocean sediments there. You know, you can go out and find the fossils of sea creatures if you look in the right spots, and rocks of the right age. But apart from that, and also that might be one of the reasons why these areas are rich in oil. I think a lot of the fossil fuel deposits are the result of there being ocean here at the time. It's like ancient plankton that forms fossil fuels. I'm about to run out of filament on that printer. I need to change this out real quick. All right, excellent. Glad I heard that noise. Otherwise, that could have been a problem. Yeah. I'm currently working on 3D printing a life-size adult Tyrannosaurus skull. It's gonna be big. It already is big. The lower jaws are enormous. Here, I'll show you. Let me go get that. But yeah, it should be maybe just a couple more weeks until we're done printing all of this, and then it'll come time to assemble it. But man, is it something? Yeah. Here, let me with Thunder Ray, let me show you what I've got thus far. Here. Bit in here. There we go. Life-size adult Tyrannosaurus, lower jaws. Pretty enormous. Yeah, this really doesn't even do it justice. Scale, it's big. It's really big. This is going to be for the Children's Natural History Museum in Fremont, California. Kids are gonna love this. But yeah, and it'll be done printing in a few weeks. It looks like I've got like 30 pieces left out of like I think it was like 190 different pieces. So we're getting right down to it, and most of the pieces that I still have left are fairly small. So. Yeah, it's gonna be good. It's gonna be really good. How's it being transported? I'll put it in my car. No? Yeah. I've got probably the most rugged and capable kind of vehicle you can buy. And it'll be perfect for transporting an adult full-size Tyrannosaurus skull, you know. Yeah. Here, my vehicle. 8, right? There we go. Ready? That's not my car there. My Prius actually looks appreciably different from this. I've got a 2-inch lift on it to bring the chassis up higher. So that also gave me room to have larger off-road tires. I've got steel underbody skid plates, a number of other modifications in order to make it into a better field vehicle. But this is what I take out into the field when I'm digging up dinosaurs. Again, this is not my exact, it's not a picture of it, but this is the same make and model and year. Yeah. Oh yeah. Yeah. Anyway, there's a ton of room in the back of this. Despite being a small car, it's incredibly spacious inside. And I will absolutely be able to fit the whole T-Rex skull in there. Looking forward to it. Yeah. But yeah. Yeah. Might be in the area next month. Yeah, Otter, go check out the Children's Natural History Museum of Fremont. There.
To have them. Both hands on here.
Kind of in the middle of a remodel right now. So we're building some new exhibits and stuff.
Yes. The Children's Natural History Museum in Fremont is a place to see.
It's a squid. Kind of little homegrown, homemade sort of museum.
And touch.
Pick one of these up.
Local history.
You can see the things, the animals that lived here a million years ago, 100,000 years ago.
And this one goes right here.
There you go.
Fossils, animals, minerals, astronomy, and more.
We're loving it. The kids are having a lot of fun. It's nice to be able to come here and touch and feel things and interact with the museum.
Anyway, that's a big part of what they do at the museum is classes for kids on the weekends and on weekdays too. Just trying to get kids in the local community interested in science and also providing a good place for field trips for local school children too. So the 3D printed dinosaur skulls and other stuff that I've brought them recently are being used for those purposes. So here, let me find photos of that. There we go. Here is the Camarasaurus skull that used to be here in our office. That is now at the Children's Natural History Museum of Fremont. These 3D printed dinosaur eggs in this nest. Also there. Teach kids about dinosaur eggs. A lovely baby Triceratops skull right there. And then this gigantic Edmontosaurus skull, which kind of wouldn't even fit in the frame. That's also there too. So yeah, it's been hard to keep up with this because like I have so many other things going on, but I am working on designing some other exhibits, and I'm in talks with the people who run the museum, basically to convince them like, hey, here's the exhibits that would be really cool to have. Here's how you can work it into your lesson plans and your field trips. This is what I can produce for you. The Tyrannosaurus skull is like a no-brainer, you know? They're gonna love that. So that's why it's such a priority right now to produce that. So, yeah. That's why I got a second 3D printer. And that's what I've been working on for the past few months. So yeah. You do good work, sir. Thank you, Emily. I appreciate that. And Nell says, where is Fremont? I will show you. So Fremont is in the South Bay Area. So it's in coastal California. Fremont is right there. So it's north of San Jose, south of Oakland, east of San Francisco. So Fremont is in kind of like, I guess you could say it's in the northern part of Silicon Valley. Yeah. Does that make sense? Anyhow. You love science museums a lot? Me too. Kenny H. Wyatt. Me too. And It's Rise TV says, is California a hard place to live? Oh, you have no idea. I mean, my goodness. You know, like beautiful scenery, and it's just so exhausting. Having a habitable temperature year-round, you know? I really miss losing fingers in snowblower accidents and stuff like that, like when I used to live in Montana, you know? It's such a chore living in this paradise of a climate, in this cosmopolitan area where you've got, you know, if you're looking for a particular kind of food or movies to watch or cultural things to do or public transit or whatever. It's all right here, you know. It's so exhausting, you know. No, it's a very easy place to live, as long as you can afford it, because it is very expensive because everyone wants to live here. But I don't know. I'm very lucky in that I've got very reasonable, very, very reasonable rent here. Which is how I'm able to survive, you know, making my living here on Twitch, doing this full time. If I had to pay, like, you know, 100% of market rate for rent, it gets pretty ridiculously expensive, which is why we've got so many folks living on the streets. Is, you know, they might be working 2 jobs and living in their car because it's just so incredibly expensive. But that's a product of A, everybody wanting to live here because it's great, and B, you know, kind of artificial scarcity in the housing market. I'm not going to go into a lot of detail about that because, I don't know, we need to be getting back to the science, but that's essentially what's going on, you know? Yeah. Yeah. And there you go, isolated. Yeah, I do actually pay rent. I know we joke about the cat landlords and all that, but, you know, I do have to pay actual USD, American dollarinos, to live here. But yeah. Yeah. It looks beautiful. I'm in Tennessee. Oh, nice. It's right. I've been to Chattanooga once, and it was a lot of fun. I really liked Chattanooga. I thought it was really charming. But yeah. Anyway, sorry if I was being sarcastic or I don't know if I was a little too froggy about that, but no, California's lovely, and I was born and raised here. I moved to Montana, to go to school and to learn how to be a dinosaur paleontologist and all that. Montana has its charms, but oh man, is it not California, you know? They do have a lot more dinosaur fossils. So do a lot of places. But they're not California. Yeah. Oh, lovely. Here's a live cam view of the Bay Area. We're just seeing the sun go down over the Pacific Ocean. There's the Golden Gate Bridge right there. This is San Francisco Bay. Down here is Berkeley, California. Can't quite see the Campanile, but the Museum of Paleontology is right down here. And there's the city. There's San Francisco. Off over there. We've got the Bay Bridge, Golden Gate Bridge, San Francisco Bay, and our solar system sun located right here. Only in California, you know? That's why they call it the Sunshine State. It is, jokes aside though, it is beautiful, you know? Yeah. Good stuff. Yeah. A little late for that view. Mount Diablo is in the way. Oh, Galrox, you're out east? Like Stockton area, something like that? Like Brentwood? Nice. Yeah. Over by Pittsburgh. Oh, nice, Skyrex. Okay, cool. Cool. Wow. Yeah, I hope you're having a good day over there. I had some friends who used to live in Pittsburgh. Near Brentwood. Nice. I've got some family over there, too. Anyhow. And moon pies are manufactured in Chattanooga. Is that right, Mayor of Space? Moon Pie the cat, she was from Athens, Ohio. Where are moon pies made? Chattanooga, Tennessee. Yeah. Well. Moon pie. I don't know if we'll be lucky enough to see Moon Pie herself on today's stream, but We'll see. Often associated with the cuisine of the American South. Interesting. Or they are traditionally accompanied by an RC cola, a remote-controlled cola beverage. Interesting. I didn't know that. They are bussin', says TV. No cap. Yeah. Good stuff. Good stuff. What a time to be alive. Yeah. Anyway, let's get back to our drifting continents and all that. Yeah.
But life there wasn't exactly a picnic. Because Pangaea was so incredibly
really
huge,
cool,
moisture from the
That is
oceans
really
couldn't
cool.
reach the interior,
Yeah.
which made most inland regions pretty much uninhabitable. And
and we were talking about this with the first dinosaurs evolving, kind of in the continental interior, potentially, of... here, getting back to our paper. Yeah. Our modeling suggests that the earliest dinosaurs might have originated in western low-latitude Gondwana. So, Gondwana is in the south. Western low-latitude Gondwana is basically like here. Yeah, this area. And so this would have been much hotter and drier than it is today. Much, much drier. Not the Amazon basin. It would have been like a desert back then.
For the world in this time. But life there wasn't exactly a picnic. Because Pangaea was so incredibly huge, moisture from the oceans couldn't reach the interior, which made most inland regions pretty much uninhabitable. And of course, making things even less picnicky were two really terrible mass extinctions. First was a Permian-Triassic extinction 252 million years ago, aka the Great Dying. It was probably caused by a series of massive volcanic eruptions from fissures in Pangaea in what's now Siberia. These eruptions likely set coal fields on fire and dumped massive amounts of CO2 into the atmosphere and oceans.
And shoot, massive amounts of CO2 dumped into the atmosphere and the oceans? That sounds awful familiar. Uh-oh. We're basically doing the same thing today. We're like trying to speed run the Permian mass extinction. It's not, boy. We'll talk about that another time. I don't have the bandwidth for it.
Eruptions likely set coal fields on fire and dumped massive amounts of CO2 into the atmosphere and oceans. The super hot air and super acidic rain and seas that followed killed almost everything. 50 million years later, the Triassic came to a close with another mass extinction, wiping out a huge number of crocodile and mammal relatives. This too seems to have been caused by volcanic activity, only this time as North America started to break away from the rest of Pangaea. But among the survivors were the dinosaurs, and as Pangaea broke apart, dinosaurs on different continents became isolated and developed into vastly different forms. The semi-aquatic Spinosaurids, for example, lived on the remnants of Gondwana. Meanwhile, horned dinosaurs like Triceratops mostly lived in North America. Then after the...
Yeah, and I actually... we'll see what he says, but I'd like to present on some research about this at the Geological Society of America meeting. Basically borrowing a ton of data that Denver Fowlers has put together over the years. I sent him an email about that right before stream today. That's why I was a few minutes late as I was working on that. But we'll see about that. The ceratopsian dinosaurs, ceratopsids, that family of horned dinosaurs with the big horns and frills, all of them are from North America so far, except for like one. We've got one that seems to make it over, that probably walks across the land bridge over into China at some point, and it's there. Sinoceratops is the only one of the ceratopsids that's not from North America, which is interesting. I do wonder if we'll find them elsewhere in the future. But right now, all of them are from North America except for one.
Then, after the KPG extinction wiped out the non-avian dinosaurs 66 million years ago, it was mammals' turn. Living on isolated continents like the dinosaurs once did, they too diversified into lots of different and weird forms. Finally, those isolated continents came into contact again in the last 5 to 10 million years, allowing animals to cross new land bridges into new environments, ones we can recognize pretty well today. But of course, things keep moving today just like they always have, at a rate of about 2.5 centimeters a year, in fact. And scientists can predict how the world might look in, say, 50 million years based on how fast the continents are moving and in which direction. So...
Yep, we'll get to that in a second, but Crimson Carnotaurus says, was South America, at least Brazil, still connected to Africa around the early Cretaceous when Spinosaurus and Oxalia and Irritator were around? I think so, yeah. Yeah, so let's go back to, let's say, 105 million years ago. They're just starting to break apart right there. So yeah, around 105 million years ago, this is basically what it would have looked like. So yeah. And I wonder if there are more ceratopsids in China. I bet you there will be Deathsaurus at some point. I bet you we'll find them. But yeah. Anyway.
Animals to cross new land bridges into new environments, ones we can recognize pretty well today. But of course, things keep moving today just like they always have, at a rate of about 2.5 centimeters a year, in fact. And scientists can predict how the world might...
So around the same rate that your fingernails grow. That's something that stuck with me since childhood. I remember reading that in a book at one point, and like every time I cut my nails, I think about that. Like, the rate at which my nails grow is generally, on average, about the same speed that continents move. Some of them are going faster than others, but it's a nice way to think about it, you know, to kind of wrap your mind around this idea that the continents are moving. That's pretty slowly.
Look and say 50 million years based on how fast the continents are moving and in which direction. So what will future Earth look like? Well,
standards.
North and South America are both moving west as the Atlantic Ocean continues to grow. Africa is moving north and will collide with Europe, probably forming a huge mountainous plateau, kind of like the Himalayas, where the Mediterranean Sea is now. Australia is also moving north and will eventually smash into the Indonesian archipelago. But beyond the next 50 million years or so, the future becomes harder for us to see. One theory called Pangaea Ultima proposes that a subduction zone will form off the east coast of the Americas, closing off the Atlantic and forming another supercontinent like Pangaea in about 250 million years. Another theory called Amasia supposes that the Atlantic will keep getting bigger and that North America will join Europe and Asia at the North Pole. And a third theory called Novopangaea envisions a future Earth that's similar to Amasia, but with the Pacific Ocean closed off, as Australia and Antarctica move into the former ocean basin. By then, of course, a 250 million years from now, our descendants and the other descendants of the modern world will have evolved and diversified to occupy a planet that looks totally different. But they'll be along for the same ride that we're on today, as forces deep within the Earth cause our idea of here to slowly drift, just as it has for billions of years.
Pretty cool stuff to think about, you know? Great way to put it into perspective, says Mondo. I agree, I think so. Yeah. Petrodactylus says, I'm so sad I won't be able to live for 50+ million years to witness Pangaea Ultima. Yeah. Although, it'd be a long, I mean, it would happen so gradually, too, that you, probably wouldn't really notice it if you were to live for another 50 million years. You get yourself into a cryo-sleep chamber or something like that. Don't let your dreams be dreams, says Mayor's Face. Yeah, you do that, Petrodactylus. You do that. Live for another 50+ million years. I believe in you. Anyway, I've got a million things that I've got to take care of tonight, and so we're going to wrap up early today. We're going to do that right now. So, and Golganak, thank you for those 42 months. And It's Rise, thank you for the 5 gift subs. Really appreciate that. Holy cow. Thank you, It's Rise, for the 5 gift subs there. Excellent. I really appreciate your support. Thank you.
ITSRIZETV just changed things with those 5 gift subs.
Appreciate you. Thank you very much for that support. There's 5 very lucky chatters.
The global and serious game of paleontology.
We won't have to watch any ads for the next month. Thank you, Crazy Kyle96, for the follow. I appreciate it. Here. Let's put a Smilodon under our credits here. And let's find somebody to raid. I've got emails I've got to respond to. I've got this North Dakota trip. I've got to start packing. I've got to test some equipment. There's a lot of stuff to do. So I hope you'll excuse us ending a little bit early today. Who else is on right now? Scient Streams. Holy cow. 4.5 thousand people watching. I think Balint might be on the front page right now. Let's go raid in. Yeah. Good stuff. Good stuff. Thank you to everybody who's showing up in our credits currently. New followers, new subscribers, resubscribers, gifters, cheerers, raiders, moderators. Thank you, mods, for all that you do. Charlie's Dragon, Mayor of Space, Lenina, Claire Burr, Salamander, Paleo Ken. Appreciate you. Thank you to the question askers and the lurkers. Thank you to the enthusers and the chat, everybody. Appreciate you very, very much. I'll be streaming again tomorrow. Hopefully not quite as frazzled and overwhelmed. I got some stuff to get done. So let's go do that, and let's go see what Science Streams is up to.